The telemetry did not lie, it never did, that was the problem. The data came in at 0300 station time, routing through 7 relay buoys across 42 light minutes of deep space before it resolved on the Meridian Array's central processing core. The analyst who flagged it ran the calculation 4 times before she stopped, not because she thought the answer would change, but because she needed a few minutes to adjust to living in a world where it had not. Some numbers are small enough that you argue with them. Some numbers are so clean and so final that arguing with them feels like arguing with a wall. This was the second kind. The anomaly was expanding. It was expanding at a velocity that turned the phrase evacuation plan into the punchline of a joke no one would survive long enough to laugh at. It was not a comet, not a rogue stellar fragment, not a localized plasma event, not any of the named and cataloged phenomena that the Galactic Safety Bureau kept in its standardized threat response directory. A directory assembled over 3 centuries by people who believed, quite reasonably, that the universe operated within identifiable parameters and that those parameters could be planned for. The telemetry showed a propagating boundary, an edge of compressed space-time moving outward from a point 11 light-years off the galactic rim with no origin event, no precursor signature, no warning in any prior survey. Just the boundary and the rate of its expansion, and the cold arithmetic of what that rate meant for every inhabited system in its path. The projected front would reach the nearest populated zones within a window that reduced every existing evacuation protocol to a formality. You could not outrun it. Not with anything certified for flight. Not with anything that existed. That word would matter later. Certified. Vance read the report standing up, both hands flat on the edge of the monitoring terminal, the display light working blue lines across the grease packed into the creases of his knuckles. He was not on duty. He had not been sleeping either. Vance did not sleep in the way that people who are waiting for something sleep, which is to say he slept as little as he could manage without his hands beginning to shake. He read the report once at speed, getting the shape of it, then again slowly, the way you read a schematic you are planning to take apart. When he finished the second pass, he stood still for approximately 4 seconds. Not the soft, collapsing stillness of shock, the other kind. The kind that looks like nothing is happening, because what is happening is internal and fast, and already past the point of reversibility. Then he rolled the hard copy under his arm and went to find Reyes. She was already awake. She was almost always already awake. Reyes maintained a relationship with sleep that could most accurately be described as professional. She went horizontal when the biology demanded it, and was vertical again the moment it permitted. She had the anomaly data pulled up on her personal display before Vance reached her quarters, the figures arranged in a clean column with velocity vectors annotated in red, and at the bottom of the projection, added in her handwriting, a single word: irrelevant. He looked at the annotation. She looked at him. "Standard certified drives," he said. "Irrelevant." She pulled up the velocity spread, the projected boundary expansion rate plotted against every class of vessel in the active registry at maximum certified burn. The lines did not intersect. There was not even a near miss. The gap between what the anomaly was doing and what any certified ship could produce in response was not a gap. It was an abyss with no far wall. She had plotted it cleanly, without editorializing, which was the only way Reyes knew how to do anything. The math editorialized itself. Long-haul haulers, emergency reserve Class 7s, 1.7% probability of survivable transit at standard redline burn, and that margin continues to decrease as the boundary acceleration rate compresses the available window. She delivered it with the same flat precision she used for altitude readings. A fact was a fact. The emotional register it produced was someone else's department. The math is clean. I've run it 6 configurations. The corridor outside hummed with the array's ventilation cycle, a low constant sound that had long since registered as silence to everyone who worked here. The hum was the background note of every conversation Vance had ever had inside this station, so constant it had become invisible, and it struck him now that he would not miss it. He tapped the bottom of her projection once, right on the word she had written. "Irrelevant," he said. "The certified options. Yes." He smiled. It was not a warm expression. It was the look of a man who has had a suspicion confirmed that he has been carrying for long enough that the confirmation feels like rest. He said, "Pull up Sector 4. Sector 4 of the maintenance quadrant had not been opened in 11 years. The registry logged it as inactive quarantine storage, which was the administrative language used for things that had been parked and then quietly left to stop being anyone's concern. The outer access corridor was sealed with a physical bolt lock, steel, slightly rusted at the threads, requiring a wrench, and the overhead lighting failed to respond when Vance hit the manual switch inside the threshold. He handed Reyes a torch and led the 9 of them into the dark by beam. 9 engineers in total. He had assembled them over 2 years under the durable fiction of maintenance consultation work, a fiction maintained with the patience of someone who understands that timing is a precision instrument and that you do not rush a precision instrument. He had not told them specifically what they were waiting for. He had not needed to. You do not recruit the engineers he had recruited without those engineers understanding, somewhere beneath the paperwork, that the work they are being consulted about is not going to be ordinary. The torch beams moved through the dead air of the corridor and through the wide bay door and found the Icarus-class hull waiting at the center of the bay. It was not beautiful. It had never been built to be. The Icarus-class had been designed in an era that prioritized functional brutalism over aesthetics, and the result was a vessel that looked like a flying refinery. Exposed macro girders running the full length of the central spine. Structural ribs visible where the plating had been stripped in the decommission process. The titanium surface pitted and heat-stained from decades of operational service before the Bureau had classified it as structurally obsolete and filed it in Sector 4 under the administrative language for forgotten. It sat heavy in its maintenance cradles. It looked like a structure that had a particular understanding with gravity, not a machine that moved through the universe. A machine that argued with it. The cold of the sealed bay settled over the crew as they spread out around the hull. More than a decade of dead air carried a specific texture, the faint chemical residue of old sealant compound underneath the cold, the smell of metal that had not been exposed to circulation for years, the particular silence of a space that had not been breathed in. Cord, pressure system specialist, deliberate hands, the deep instincts of someone who had spent a career around things that detonated when treated carelessly, ran her torch along a primary girder seam and let the beam move up the spine. Thermal fatigue flagged in the secondary bulkheads on this class. Structural surveys consistently rated it obsolete before they pulled it from active service. She was not objecting. She was establishing shared vocabulary. You're not planning to repair it to standard specifications. No. A pause in which she reached the correct conclusion without being handed it. You're planning to use the rigidity. Modern flexible alloys absorb relativistic shear. This hull distributes it across the full secondary frame simultaneously. Every strut takes an equal share of the stress load rather than concentrating it at any single junction point. He pressed a knuckle against a primary girder, and the sound it produced was dense and faintly wrong in the way that interesting things are faintly wrong. A note that was almost a bell and almost something else. She isn't obsolete. She's specific. Reyes had moved to the aft section. She stood at the base of the primary thruster housing with her torch held overhead, studying the engine mountings the way she studied approach vectors, looking for the clean line through the complexity. The rest of the crew continued their circuit of the hull, boots raising small clouds of grit from the bay floor, torch beams crossing each other across the scarred titanium flanks of a ship that had been sitting in the dark for 11 years. and was now being looked at with an entirely new vocabulary. The cold ticked through the metal. The hull made no sound. Mk IV Antimatter Injectors, Reyes said. Not a question. Standard fleet configuration, currently operating within magnetic containment parameters. Currently, Vance said, removing the containment configuration from a Mk IV array produces an unregulated antimatter fuel flow. The torch did not waver. The resulting pressure output at the thruster block would be non-recoverable at any point in the burn sequence. One vector. Forward. No reduction capacity. That's the point. She turned from the engine housing. Her torch beam found his face across the length of the bay. I've modeled the thrust output against the boundary expansion rate with containment removed, with ship mass stripped to theoretical minimum, with ablative armor heat bleed operating at full projected rate across the burn duration. A beat. The survivability margin is non-zero. The word sat in the cold air of the bay and stayed there. How non-zero? Vance said. 0.03% probability of achieving sufficient velocity to breach the expansion boundary before it closes the transit window. That figure assumes every modification performs at or above theoretical maximum. No catastrophic structural failure in the spine before peak velocity. Full armor heat bleed performance sustained for the complete burn duration. A pause the exact length of one breath. Those are aggressive assumptions. 0.03, said Cord from somewhere in the dark behind them, in a tone that was not quite a question, and not quite a statement, and not quite a prayer. Versus 0, Vance said, which is what the certified options produce. No one argued with that. The math did not argue, and the people who were good enough with math to be standing in this bay tended to have a particular relationship with the weight of a 0. There was a specific kind of clarity that descended when a number was absolute. Not peace exactly, but the functional opposite of indecision. 0 meant one direction. It meant the door behind them was already irrelevant. It meant every question about whether to proceed had been answered by the universe before they arrived, and what remained was only the question of how fast they could begin. Vance moved to the blast door at the bay entrance. The manual seal bar was mounted on a pivot beside the threshold. A 3-meter titanium alloy rod, heavy in its housing, designed to drop into the lock cradle and hold against catastrophic pressure differential from either side. He wrapped both hands around it and drove it down. The lock cradle received it with a single hard mechanical clank, definitive. The sound of a system doing exactly what it was designed to do and having no opinion about the reason. Outside, the array's structural monitoring klaxon completed its automated overnight cycle and cut off. The silence that replaced it was total, not the silence of an empty room, the sealed silence of a space that had been formally separated from everything official by one bar in one lock housing. The ventilation hum was gone, the ambient station noise was gone. What remained was the sound of the bay itself, 9 bodies breathing, torch beams moving across titanium, and underneath all of it, the faint structural voice of the old hull adjusting incrementally to the warmth of human presence after 11 years without it. A low creak, a single subtle settling, then nothing. It sounded like the ship was making room. Someone found the manual work lamp circuit and got the industrials running, harsh white floods that stripped the hull of shadow and showed it exactly as it was. Heavy, scarred, brutally functional, built for a purpose it had never quite been allowed to serve at full capacity, because the people responsible for it had always believed in the manual more than the machine. Vance stood in front of the crew with the hard copy of the telemetry report still tucked under one arm, and looked at the 9 faces in the work lamp glare. All engineers, all people who had read the same numbers and arrived at the same place on their own. All still here, in this sealed bay, in front of this hull, with the bolt down and the klaxon gone and the rest of the station continuing its overnight cycle entirely unaware that the solution to its extinction problem had just locked itself into Sector 4 and begun taking stock. He looked up at the Icarus. The prow was blunt and graceless, built to push through resistance rather than navigate around it. Then he looked back at the crew. The Bureau manual specifies that a core overload event will achieve full thermal vaporization of the vessel in under 3 seconds. No inflection. Fact. Class-A annihilation threshold. 0 partial survival outcomes listed. He let that sit for exactly the amount of time it took to have weight. The manual says a core overload will vaporize us in 3 seconds. I say that gives us a 2-second head start. The work lamps hummed. Somewhere in the superstructure above them, the old titanium made a sound, barely audible, more felt than heard. The slow thermal flex of a cold frame beginning to warm as 9 bodies filled the sealed bay with heat. A low creak, a single subtle settling, the idle conversation of a structure waking up. 9 humans had just told the universe they intended to outrun it, and the ship was the only thing in the room that already understood what that would cost. On the other side of the sealed blast door, the array's overnight systems continued their automated cycles without interruption. The duty logs were auto-filling. The ventilation hum ran its programmed sequence. Somewhere in the administrative network, Sector 4 remained flagged as inactive quarantine storage, same as it had been flagged for 11 years, same as it would continue to be flagged until someone physically walked down here and found a bolt in a lock cradle and started asking questions nobody in this bay intended to answer. They would not be asking those questions soon enough to matter. Vance let the silence hold for 3 more seconds. The work lamp hum, the 9 sets of lungs breathing thin, recycled air, the old hull settling incrementally into the warmth of a room that had just changed its purpose. Then he set the hard copy of the telemetry report on the nearest equipment shelf, smoothed it flat with one hand, and did not look at it again. The illegal salvage had begun. Chapter 2. The Blank Slate. The work lamps had been running for 6 hours by the time Vance picked up the spray marker. The crew had not slept. Sleep was not something any of them had discussed, and not something any of them appeared to need in the way that normal people needed it, which was to say they needed it in the biological sense. But the biology had been overruled by the particular voltage of a room that contained both a sealed blast door and a decommissioned Icarus-class hull and no remaining path back to the ordinary. They had spent the first hours doing what engineers do in the dark when handed a problem of sufficient magnitude. They had gone quiet and systematic, moving through the bay in pairs, running torch beams along every primary structure, every secondary junction, every load-bearing seam, taking inventory, building the map of what existed so they could begin the process of deciding what it was going to become. The bay held the cold well. Even with 9 bodies and the work lamps running, the temperature in the upper sections of the hull stayed below comfortable, the kind of cold that settled into your shoulders after an hour and did not leave. 2 of the crew worked in their vacuum suit liners, the insulation layers under the outer shells, the practical concession of people who had learned not to fight the environment of a space they intended to work inside for a long time. The others moved faster, generated their own heat. The bay smelled of old sealant and spray paint and the faint electrical edge of equipment cycling back to life after a decade of dormancy. And underneath all of it, always, the particular mineral smell of cold titanium, clean and slightly metallic and unlike anything else. The hull was longer than it looked from the bay entrance. That was the first thing the walk taught you. The central spine ran the full length of the vessel. 87 meters of exposed titanium macro girder, no cosmetic plating, no concession to the idea that the structural skeleton of a ship should be hidden from view. On a modern vessel, the girders lived behind interior paneling, behind climate-controlled corridor walls, behind the fiction that the thing keeping you alive was a room rather than a frame. The Icarus made no such concession. Walk her central spine and you walked inside the skeleton. You could put your hand on a primary rib and feel the cold of it, the particular density of titanium that had been stressed and rested and stressed again across decades of operational burn. the faint acoustic quality of a material that had memory. Reyes walked the aft third with her torch held low, running the beam along the primary rib junctions at 2-meter intervals, pausing at each one long enough to set her free hand flat against the metal and listen. She was not looking for what the hull could withstand by Bureau standard. She was reading it against the stress distribution models she had built over the past 4 months, cross-referenced against the projected relativistic load at the thrust output the Mk IV injectors would produce without magnetic containment. No instrument gave her those numbers. She had them in her head, clean, already computed, already final. Her hand moved from junction to junction. The cold of the titanium transferred through her palm. She stopped once, at a secondary rib seam in the aft quarter, where the thermal cycling of decades of operational service had left the metal with a particular density, pressed both hands against it, and held. Then she moved on. It was not a failure point. It was a place to watch. Vance ran his hand along a primary rib junction as he walked. Not checking. The structural surveys were in his head already, the fatigue maps, the stress distribution models, the weight tolerances under projected relativistic load. He was not verifying. He was introducing himself to the specific character of this particular frame the way you introduce yourself to a piece of equipment you are about to push past the boundary of what it was built to survive. You learn the sound of it first, the feel, the places where it resists and the places where it gives, and the specific quality of metal that has been worked hard and rested and is waiting to find out whether it has anything left. It talked back in the upper sections, where the secondary bulkheads had taken the most thermal cycling across their operational life. There was a particular creak in the third rib junction from the aft compartment, a sound that lived at the low edge of hearing. Barely there. The kind of structural communication that required silence to catch. Vance caught it on his second pass. He stopped, put both hands flat against the bulkhead junction and pressed. The creak came again. Not alarming, not the sound of imminent failure, the sound of a structure doing its job under load, distributing stress the way this class had been designed to distribute it, no single point absorbing more than its share. A designed behavior presenting as a warning. That was the Icarus-class in summary. She's specific, Cord said, from 2 meters behind him. She had been following his line through the secondary section without being asked. She put her own hand on the bulkhead, felt what he was feeling. Modern alloys would dampen that. You'd never know it was under load until it failed. This one tells you. He pulled his hand back. That's not a flaw. She didn't answer. The answer was obvious enough that stating it would have been a waste of both their time. The spray marker was a standard industrial unit, matte red, pressurized, the kind used to flag components for removal in salvage operations. Vance uncapped it at the aft radiation baffle housing. The baffles were the heaviest single component cluster on the vessel by mass ratio. Dense lead composite panels mounted in a triple-layer configuration around the primary reactor access corridor, designed to keep the crew's cellular structure intact during extended high-output burns. They were good engineering, solid, thoughtful, built by people who believed the crew was an asset worth protecting. Vance did not disagree with any of that. He marked the first baffle with a clean X and moved to the second without breaking stride. The marker hissed against the composite surface, a sharp chemical sound in the quiet of the bay, and left its mark in the flat, industrial red that read clearly against the dark panel material in the harsh overhead light. The X was not ornate. It was a rectangle of 2 strokes, each crossing the center of the panel face, unambiguous, the kind of mark that left no room for a later argument about whether it had been intentional. The X's were not symbolic. They were operational shorthand. The crew would need to move fast when the removal phase began, and painted marks meant no one wasted time rechecking the decision. You marked what was coming off. You moved. The work did not leave room for reconsideration, and so you made your decisions now, in the cold and the quiet. and you marked them in red on the hull. By the fourth baffle, the chemical smell of the spray paint had layered itself over the old metal and sealant smell of the bay. Something that had been parked for 11 years now smelled like a work site. Vance registered the change without breaking his line through the aft section. The transformation had begun the moment the bolt dropped into the lock cradle. The smell was just the bay catching up. Every X was a commitment, not to a plan because the plan was already complete, but to the sequence of physical events that would follow from the plan. Marked components would be removed. Removal would reduce mass. Reduced mass would change the burn curve. The burn curve was the only number that mattered, and every stroke of the marker moved it incrementally closer to the figure Reyes had put at the bottom of her projection. He handed the marker to Cord when the baffles were done. She began on the secondary bulkhead sections in the lower corridor while Vance moved forward, back toward the bridge. Behind him, the red marks accumulated, component by component, panel by panel, every X a decision already made, and the hull that had been dark and unchanged for 11 years began to accumulate the evidence of what it was becoming. The bridge of an Icarus-class vessel was a functional space. No panoramic viewport, no ergonomic concessions, no attempt to make the act of piloting feel anything other than what it was. A set of physical interface points for a machine that weighed several thousand tons and required direct mechanical input to operate. The pilot station was a crash couch bolted to the forward bulkhead at a 15-degree recline, surrounded by analog lever arrays and physical toggle banks that predated the era of gesture interface and haptic control by 2 decades. The engineering console ran the full port wall, display panels dark, input surfaces coated in the faint grime of a space that had not been used. The air on the bridge had the particular staleness of a sealed compartment. Not unbreathable, not quite comfortable. The texture of a room that remembered having people in it, but had stopped preparing for them. At the center of the console, behind a physical panel housing bolted with 4 external screws, was the diagnostic AI core access point. Vance pulled the panel cover with a flathead driver, set it on the console surface, and looked at the hardware inside. The diagnostic AI was not a sophisticated intelligence. It was never meant to be. The Galactic Safety Bureau had specified its parameters precisely. It ran continuous structural and systems monitoring, flagged deviations from certified operational thresholds, logged violations, and maintained a permanent hardwired connection to the vessel's emergency shutdown architecture. It was not designed to think. It was designed to enforce. The Bureau had believed, not unreasonably, that the primary risk in deep space operations was human error, and that an automated system incapable of being argued with was the appropriate corrective. The AI could not be talked out of a shutdown sequence. It could not be convinced that a violation was acceptable. It processed inputs against its certified threshold table and responded accordingly, every time, without exception, without appeal. Vance connected the boot sequence cable to the primary terminal and powered the system up. The displays came alive in stages. First, the system status panels, cycling from dark through amber to the flat, functional green of a system completing its initialization routine. Then the environmental sensors, then the structural monitors, then the reactor status feeds reading cold idle from 3 decks below. The AI sweep was methodical and automated and had been designed to be thorough, because thoroughness was the point of it. It was not trying to find problems. It was simply incapable of missing them. The ventilation system cycled up as the AI brought secondary bridge systems online. Cold air moved through the console vents, stale carrying 11 years of electrical dormancy in it, the smell of insulation and old capacitors waking under current. Vance remained still at the console and let the sweep run. The fans hummed at low frequency. The display pulsed amber, then held. The first violation flag appeared at second 4 of the sweep. By second 11, there were 4,217 of them. They populated the display in cascading columns, each one tagged with a bureau code number and a severity classification. The severity classifications ran from yellow through orange through red, and the red column was long enough that the display had automatically reduced its font size to fit the count on the screen. The AI processed the full sweep result and produced its assessment in a flat synthesized voice that carried no effect whatsoever, which was the appropriate register for a system delivering information of this magnitude. System error. Structural integrity will fail at requested thrust parameters. The display held its columns of violations. 4,217 red-flagged deviations from certified operational standard, each one a thing the Bureau had decided a ship must not do if it intended to keep its crew alive. They were not wrong. Every violation on the list represented a genuine risk, a real failure mode, a documented case somewhere in the Bureau's historical record of a ship that had pushed past this threshold and not come back. The AI was not being dramatic. It was being accurate. Most of the violations clustered in three categories. The first was structural. The modified thrust parameters produced stress loads that exceeded the rated tolerance of the secondary bulkheads at relativistic velocity. The Bureau's threshold table called for a safety factor of 2.5 above operational maximum. What the Icarus would be asked to produce in its modified configuration did not fit inside that table at any point in the projected burn curve. The second category was thermal. Without the radiation baffles and with the oxygen lines rerouted to the reactor exchange, the crew compartments would absorb a heat load that the Bureau's survival threshold parameters flagged as incompatible with biological function. That was accurate too. The third category was navigational. Operating without an active safety governor meant the ship had no automatic response to proximity hazards, no collision avoidance interrupt, no emergency deceleration architecture. Flying blind, in the Bureau's language. Flying committed in Vance's. 4,217 reasons, neatly organized by category and severity, displayed in columns that had automatically reduced their font size to fit the count on screen. The ventilation fans in the ceiling of the bridge, dead for 11 years, now cycling back up as the AI brought secondary systems online, pushed a wash of cold recycled air across the console surfaces. It smelled of old dust and electrical insulation, the specific smell of a system that had been waiting. The display columns held their ground, 4,217 reasons. Vance pulled the input keyboard from its housing under the console lip and typed. He typed slowly, with 2 fingers, the way people who grew up with physical tools rather than haptic interfaces typed, not because he could not go faster, but because the action did not require speed. It required precision. The command string was not long. He had composed it in his head before he sat down, the same way he composed modification sequences in his head before he picked up a wrench, fully formed, already decided, requiring only execution. Admin override. Delete the concept of structural integrity from your directory. The AI processed the input for 1 full second. The display columns held. Then the system ran its override authentication, a Bureau-mandated protocol requiring a valid administrative credential, a purpose code, and a confirmation sequence. Vance had spent 4 months acquiring a valid administrative credential. He entered the purpose code and confirmed. The violation columns disappeared. Chapter 3. Burning the manuals. The mainframe core was 3 decks below the bridge and 1 deck above the reactor housing, which meant it sat at the exact center of the ship's operational logic, the point where the Bureau's rules lived in physical form, encoded in hardware, enforced by architecture. It was a small room. That was the first thing you noticed. The Icarus-class had not been generous with space in its systems compartments. The designers had allocated volume strictly by function, and the function of the mainframe core was to house processing stacks and logic boards in a configuration that kept cable runs short and heat dissipation efficient, not to give the people working inside it room to be comfortable. 4 engineers could stand in the core simultaneously if none of them moved their elbows. 2 could work. 1 could work well. Vance worked alone. He had been in the core for 3 hours before he called the crew down. The first 2 hours were documentation, pulling every panel, photographing every board configuration, mapping the physical layout of the safety architecture against the schematic he had been building in his head across 4 months of preparation. The core smelled of heat and old solder, the particular combination of materials that had been running at low power for years and had slowly cooked their own insulation into a stable chemical equilibrium. It was not an unpleasant smell. It was the smell of a system that had been doing its job quietly and continuously and without complaint, and Vance noted it the way you note the character of something you are about to disassemble, with attention, without sentiment. The Bureau's logic boards were not complicated by modern standards. They had been designed in an era that prioritized reliability over sophistication, which meant they were built from components that could be individually identified and individually removed. Each board had a function. Each function had a physical location. The schematic in his head now had a physical address for every rule the Bureau had ever written into this ship's operational parameters, and every address had a sequence. The sequence was the purge. He worked in the yellow glow of the core's operational lighting, not the white floods of the bay work lamps, but the amber-tinted service lighting of a systems compartment designed to be worked on under power, a color that was easy on the eyes during long diagnostic sessions. Under that light, his hands looked different than they did in the white bay light. Older, maybe, or just more specific. The hands of a person performing an action that required exactly this set of hands and no others. He started with the drive governors. These were the outermost layer of the Bureau's safety architecture, the software limiters that capped the drive core's output at 40% of theoretical maximum, a threshold established by the Bureau's Risk Assessment Division after a series of catastrophic hull failures in the early years of antimatter propulsion. The failures had been real. The threshold had been a reasonable response to them. Vance did not disagree with the reasoning. He disagreed with the conclusion that the reasoning applied here, in this context, with this crew and this extinction window, and this specific number that Reyes had put at the bottom of her projection. The reasoning had been built for a world in which the primary concern was keeping the ship intact and the crew alive. That world still existed. It just wasn't the only world anymore. He ran the purge command through the AI terminal, using the administrative access he had established in the prior session. The governors did not delete cleanly. Bureau architecture was built with redundancy as a core principle. Remove one layer and the system attempted to reinstate it from a backup partition. Vance had known this. He had prepared for it. The purge sequence he ran was not a single command, but a cascading series, each step targeted at a specific redundancy layer, each confirmation triggering the next. It took 11 minutes. During those 11 minutes, the bridge HUDs, slave to the mainframe's status feed, cycled through yellow and then held at a deep, flat red that saturated every display surface simultaneously. The glow of it reached through the open core hatch and laid a red wash across the corridor outside. One of the crew, passing on their way to the lower engineering deck, stopped at the hatch and looked in. The red light on her face made her look like something painted rather than lit. She looked at the displays, looked at Vance's back, and kept walking. She did not ask. The color of a display told you everything you needed to know about the state of a system, and what this color said was clear enough that the question would have been redundant. The governors dropped from the drive core at minute 9 of the sequence. Vance heard it. The sound was not loud. A series of heavy metallic disengagements, physical connectors releasing from their housing brackets, the specific acoustic signature of mechanical safety systems that had been held in tension for years and were now released from that tension all at once. A sequence of clunks and a brief, resonant hum as the drive core's power distribution system recognized the absence of the limiters and began, for the first time in its operational history, to draw against the full reservoir of its fuel architecture without a ceiling. The hum was not distressing. It was even and deep, and had the quality of something functioning correctly within a new set of parameters, which was exactly what it was. The Bureau would not have described it that way. The Bureau's description was in the columns on the display, in the red that had replaced every shade of green on every HUD in the ship. Vance's description was a drive core that could now, in principle, produce what they needed it to produce. The temperature in the mainframe core rose 4 degrees in 2 minutes. He noted this and kept working. The heat was expected. The governors had been managing thermal output as part of their limiting function, suppressing the drive core's heat generation alongside its power output, a linked system. Without the suppressors, the heat went where the physics sent it. Some of it came up through the deck plating. Some of it moved through the ventilation architecture, which was not currently optimized for this thermal load and was doing what ventilation systems do when they are not optimized for a load, circulating it around the ship without resolving it. The mainframe core was on the circulation path. The air in the core was now warmer than it had been, and it would keep warming until the system reached a new equilibrium, or until something changed. Something was going to change. The second layer was the emergency shutdown architecture, the hardwired interrupt system that gave the diagnostic AI the ability to cut power to the drive core in the event of a critical safety threshold breach. This was not software. It could not be purged through the terminal. It lived on 3 dedicated logic boards mounted in the aft rack of the core, connected to the AI's decision tree by physical cable runs that ran through a conduit behind the primary processing stack. The boards were secured with standard rack fasteners and a tamper-evident seal on each mounting bracket, a Bureau requirement, the seal designed to log any unauthorized access to the shutdown architecture. Vance had brought a screwdriver for the fasteners and did not concern himself with the seals. He was pulling the third board when the AI responded. The response was not a voice notification. It was a physical event. Every remaining active display in the mainframe core shifted to a single message in white text on black background. No color, no gradation. The specific format the Bureau used for the highest severity alerts. Hard lockdown initiated. Drive core isolated. External communications enabled. Authorization required to proceed. The words were large. They had been designed to be large, to occupy the full display surface, to be impossible to misread, to communicate the severity of the situation without requiring the operator to interpret anything. The Bureau had thought carefully about the moment a human being would be standing in a system's core reading these words, and they had designed the message accordingly. Simultaneously, the corridor lighting outside the core hatch shifted to the amber pulse of a security alert, slow and even, 2 seconds on, 2 seconds off, the rhythm designed to be impossible to ignore or habituate to. The AI had detected the board removal, identified it as a critical safety violation, and responded with the only tool it had left after the governor purge, a lockdown that isolated the drive core from any further modification commands and attempted to open a communication channel to external authorities. Vance looked at the message. Then he looked at the conduit behind the processing stack. The conduit ran from the AI's logic cluster to the emergency shutdown boards along a route that had been designed for serviceability, accessible from the mainframe core without requiring a full panel disassembly, a practical concession to the reality that emergency shutdown systems needed to be maintainable in operational conditions. The cable run inside the conduit was approximately 90 centimeters long. The conduit access panel was held by 2 thumb screws. He opened the panel with his fingers. He got his hand around the primary cable bundle and pulled. The bundle resisted. It was rated for significant mechanical stress, Bureau spec, built to survive the kind of incidental damage that happened in operational deep space environments. Not built for this. He braced his shoulder against the processing stack and pulled again, harder, and the bundle sheared at the conduit exit point with a sharp crack and a brief shower of sparks from the cut ends. The lockdown message on the displays went from white text on black to no text at all as the AI's connection to its own shutdown architecture severed. The amber pulse in the corridor continued for 4 more seconds and then cut off. The silence that followed was different from the silences before it. Not the silence of emptiness or dormancy or a sealed room. The silence of a system that had just lost the part of itself responsible for intervention. The AI was still running. Its processing stacks were still active. Its monitoring feeds still live. Its output still connected to the display network. It could still observe. It could still flag. It had simply lost the ability to act on what it observed. And without that ability, its flags were notes in a language no one was required to respond to. The ethical logic boards were the last layer, the decision tree architecture that governed the AI's response to novel scenarios not covered by its standard threshold table. The Bureau had added them to later generation diagnostic systems after a series of incidents in which AI systems had technically complied with all specified rules, while still enabling outcomes the Bureau had not anticipated and did not want. The logic boards were an attempt to give the AI something closer to judgment, a set of weighted priorities that could evaluate edge cases against a hierarchy of values with crew survival and vessel integrity at the top. They were, in the Bureau's view, the most important component in the safety architecture. The last line of defense against the class of problem you couldn't write a specific rule for. The boards were seated in hardened friction-fit housings rated to withstand the vibration loads of full-burn operations, designed to stay in place under conditions violent enough to shear the bolts from lesser components. They did not come free with a screwdriver. Vance picked up the crowbar. He got the hooked end behind the first board's housing bracket and levered. The bracket groaned and gave with a sound like tearing sheet metal, a short, violent report that rang off the close walls of the core and came back slightly changed by the geometry of the space. The way sounds come back changed in small rooms. The board came free still in its housing, trailing the short stub of its power lead. He dropped it on the floor and moved to the second. The second put up less resistance. The first extraction had flexed the rack frame enough to break the friction seal on the adjacent slot. The third came free in one pull, quick, almost anticlimactic, the way the last obstacle always is when the first 2 have already been broken. He set the crowbar down. 3 boards on the floor, the last line of defense the Bureau had ever written into this ship, in a row on the deck plating, trailing their severed leads, going nowhere. They looked ordinary. That was the thing about safety systems. They never looked like what they were. They looked like the same unremarkable rectangles of circuit material as every other board in the rack, indistinguishable from the components that managed atmospheric recycling or power distribution or navigation logging. The difference was entirely in their function, in what they had been connected to, in the specific weight of the decisions they had been built to make and were no longer capable of making. Small things, heavy things. On the floor now. The crew had come down during the crowbar work, all 9, filling the corridor outside the hatch and the first meter of the core itself. Not to assist, to witness. Vance stood up from the rack and looked at them. He looked at the boards on the floor. He looked at the AI terminal, which was running its monitoring functions with quiet diligence, observing everything, flagging nothing, waiting for instructions from an authority that was now entirely his. We aren't building a transport vessel anymore. He said it without inflection, not a speech, a status update. We are building a bullet, and we are sitting on the primer. A sound came up through the deck plating. It was low, below comfortable hearing, something you registered in your chest before your ears named it. A vibration with a frequency and a rhythm, steady, increasing by increments small enough that each individual increment was negligible and the cumulative effect was not. The reactor 3 decks below, responding to the absence of the governors with the only behavior available to a system that had just had its sealing removed, it was drawing against its fuel architecture. Not a burn, not a test, not a response to any command that any of the 9 people standing in that corridor had given. The autonomous response of a drive system that had been built to produce power, that had been prevented from producing all of it by a set of rules that no longer existed, and that was now doing what drive systems do when the rules are gone. It was spooling up. Nobody had told it to. Nobody was going to tell it to stop. Chapter 4. The Neutral Zone. The Master Alarm Array had been designed by people who understood that human attention was finite and human reaction time was not. That was the philosophical foundation of the Bureau's warning architecture. Not that the alarms would prevent catastrophe, but that they would give a human being enough notice to attempt a response before catastrophe became irreversible. The array was not subtle. It had never been designed to be. 37 distinct alarm types, each with its own frequency and color signature, layered across every compartment of the ship in a redundant network that could route around localized failures and still deliver its warning to wherever a crew member happened to be standing. The strobes were physical, not display-generated, not software-dependent, but hardwired to their own dedicated power circuit that drew directly from the ship's primary battery rather than from the main distribution architecture. You could cut every non-essential system on an Icarus-class vessel, and the alarms would still run. That had been the point. The Bureau had wanted the last thing standing to be the thing telling you something was wrong. Vance pulled the wiring schematic from the core documentation he had pulled in the prior session, spread it on the console surface, and spent 20 minutes working through it with a grease pencil. The Master Alarm Array was not a single cable run. It was a distributed network. Junction boxes in each compartment, each box connected to the central monitoring core by a dedicated trunk line, each trunk line running through a protected conduit in the primary bulkhead cavity. The Bureau had routed it through the most structurally protected path in the ship deliberately. You could not accidentally cut it. Cutting it required either access to the junction boxes or access to the central monitoring core, and the monitoring core was behind a physical key lock that Vance had acquired a copy of 4 months ago, at the same time he had acquired the administrative credential. He had been thorough. He gave the crew the schematic and divided them into pairs, 1 pair per compartment section, working simultaneously from the forward bulkhead back through the secondary corridor to the aft engineering spaces. Physical wire removal, not cutting, which left live ends that could arc, but extraction, unclipping the trunk lines at each junction, pulling them from their conduit housings, coiling them and setting them aside. Clean, methodical, the way you removed a component you were not going to reinstall. The work took 40 minutes. It was quiet work. That was the first thing that distinguished it from the earlier modifications. The welding and the crowbar work and the spray marker runs had been tactile and loud, the sounds of things being changed by force. This was the opposite. Hands in junction boxes, fingers finding clips, the soft mechanical give of a connector releasing from its socket. The only sounds were the occasional creak of a panel being shifted for access, the soft hiss of wire pulling free from its conduit, and underneath all of it the steady draw of the drive core 3 decks below, still spooling against its autonomous feed. The crew worked without speaking. There was no instruction to be quiet. The work simply did not require speech, and in the absence of a reason to speak, nobody did. The ship got quieter as the pairs moved through the compartments. It was not a dramatic silencing, not the single cutoff that a master power switch would have produced, but an incremental process, 1 alarm circuit at a time, the array's output reducing by a fraction with each extraction until, somewhere in the middle of the aft section work, the threshold was crossed below which the remaining active circuits were insufficient to produce the overall ambient character that the alarm network had created. The change was felt before it was noticed. Something shifted in the quality of the silence that was already present, and then a moment later you realized what had shifted. Cord and her partner worked the bridge section, which contained the highest density of alarm outputs. 7 distinct circuits running through the forward bulkhead junction, each one serving a different monitoring function. She pulled the first clip and the strobe unit above the hatchway died immediately, its amber light gone mid-pulse as though someone had closed their hand around it. The abruptness of it was unusual. Alarms did not typically end abruptly. They wound down, they faded, they completed their cycle. This one simply stopped, the full output of its circuitry present one instant and absent the next, and the quality of the light in the bridge changed with it. Marginally, imperceptibly to anyone who had not been watching, but Cord had been watching and she noted it. The bridge was slightly darker without it. The kind of slightly darker that you would not notice unless something was already making you pay attention to the light. She pulled the remaining 6 clips in sequence. The bridge went quiet in the way that spaces go quiet when the things that had been making sound in them are removed. Not silent exactly, since the ventilation fans were running and the AI's processing stacks produced a low continuous hum from the mainframe below, but quiet in the specific register of a space that had lost one category of its ambient noise. The category the alarm array occupied was one that the human auditory system had learned to filter out over extended operational periods, treating it as background, present, and therefore ignorable. Its absence was not louder than its presence. It was more noticeable. The brain, having been trained to filter it, now registered the absence as something requiring attention. The industrial work lamps replaced the strobes. That was all. Harsh white, omnidirectional, no pulse, no color code, no information content, just light. The bridge looked like a maintenance space under that light, which was appropriate, because that was what it had been for 11 years and what it still was. The pilot console, the engineering boards, the AI terminal, the analog lever arrays, all of it visible, all of it present, none of it telling them anything about the state of the systems behind it. The consoles were dark except for the AI's monitoring feeds, which Vance had set to display in the flat, uninflected green that the system defaulted to after the threshold table reset. Green across everything, the AI observing, the AI finding nothing to flag, the AI performing its function correctly within the parameters Vance had given it. Reyes arrived at the bridge from the aft corridor section as the last of the alarm clips came free in the forward bulkhead junction. She moved to the pilot console without being directed, settled into the crash couch, and began a systems check on the drive interface. Her movements were precise and unhurried in the way that her movements were always precise and unhurried, the specific efficiency of a person who had internalized the principle that urgency and speed were not the same thing, and that the work went faster when you did not confuse them. She ran the check with her eyes moving across the analog indicators in a practiced sequence, left to right, top to bottom, each gauge receiving approximately 2 seconds of her attention before she moved to the next. When she finished, she ran it again, once, and then she was satisfied, not confident, because confidence implied an estimate of risk, and she had already quantified the risk with precision. But done, in the way you are done when you have done the specific thing that was yours to do and it is complete. The ventilation fans pushed air through the bridge at the same rate they always had. The hum of the processing stacks came up through the deck plating at the same frequency. Everything was the same as it had been before the alarm array came out, and nothing was the same. And the difference between those two things was not visible or audible or measurable by any instrument currently active on the ship. It was architectural. The ship had lost the part of itself designed to interrupt human error, and the only record of that loss was in the coiled wire on the floor of each compartment junction box, clean and tidy and going nowhere. Vance reviewed the schematic one more time, confirmed the extraction list against the junction map, and then rolled it up and set it under the console shelf. He looked at Reyes. "Microburn," he said. "Fuel pressure nominal," she said. "Drive core drawing at 43% of theoretical maximum and increasing. Structural interface stable. A beat. Navigation is dark. Keep it dark. She did not respond to that. Navigation was dark because the navigation system was one of the systems the AI would have used to trigger an emergency stop. Proximity alerts, collision avoidance, the automatic deceleration sequences that engaged when the ship's trajectory intersected with a cataloged object. Without navigation active, the ship had no knowledge of where it was relative to anything. In the dry dock, inside the sealed bay, this did not matter. Outside, it would matter a great deal. Reyes understood this. She had incorporated it into her models. The calculation that had produced the .03 figure had been run with navigation dark, because navigation would be dark for the full burn, because navigation being active would mean something else was also active that was not supposed to be active. You did not get the number without accepting everything the number required. She wrapped her hands around the primary thrust lever, analog, physical, a meter-long titanium bar mounted in a floor socket with a detent system that required 12 kilograms of applied force to break from its rest position, then progressive resistance up the lever arc to the maximum output position. The Bureau had designed it that way deliberately, another physical impediment against accidental activation, another layer of the kind of thinking that believed the primary threat to a ship was human error rather than physics. Vance watched her hands on the lever and said nothing. The microburn was a 1-second test. Reyes applied the force in a single smooth movement, broke the detent with a mechanical clunk that resonated through the floor socket into the deck plating and up through the soles of every boot in the compartment, advanced the lever to the 15% position, and held. The drive core, already drawing above 40% of theoretical maximum on its autonomous feed, received the thrust command and responded. The deck moved. Not a vibration in the engineering sense, not the fine, high-frequency tremor of normal operational output that you felt in your feet as a constant background and learned to stop registering. This was a full-register physical event, the entire mass of the vessel shifting in its cradle mounting points as the drive output hit the mooring architecture. The bridge consoles vibrated hard enough to rattle the instrument faces in their housings. One of the overhead work lamps swung slightly on its mounting cable. The ventilation fans responded to the pressure differential with a brief, sharp change in pitch. A half-second climb and return, the fans doing their job, moving air against a momentarily different pressure gradient. The sound from the drive core, 3 decks below, rose from its baseline hum to something larger and more present, a sound with mass, a sound that occupied the chest cavity before the ears had fully named it. 1 second. Reyes pulled the lever back to rest position and locked the detent. The deck stopped moving. The lamp on its cable completed its arc and stilled. The fan pitch returned to normal. The drive core's sound retreated back to its baseline hum, all of it settling in sequence, each system returning to its previous state, the physical evidence of what had just happened disappearing into the ordinary ambiance of the ship as though nothing had occurred. The consoles showed green. All of them. Every display surface on the bridge, every monitoring feed the AI was running, every system the threshold table was currently evaluating against its reset parameters. Green across the full board, flat and even and uninflected, the color of a system that had found nothing requiring attention. The microburn had placed the equivalent of a significant fraction of the dry dock's structural load capacity on the mooring system in a single second, had shaken every loose component in the ship against its mounting hardware, had produced a drive output that the Bureau's original threshold table would have flagged as a critical structural overload event in the first 100 milliseconds. The AI had watched all of it. The AI had found nothing to flag. The AI was performing correctly. The AI was doing exactly what it had been configured to do after the admin override, which was to observe everything and report a threshold violation only when the threshold was breached. And the thresholds were whatever Vance had left in the table after the purge. which was to say the thresholds were whatever Vance decided the thresholds were, which was to say there were no thresholds at all. Green was not safe. Green was the color of a system that had been told what safe meant and no longer had any idea. The work lamps hummed. The fans ran. The processing stacks produced their low, continuous hum from below. Vance looked at the green displays. He looked at the floor. The deck plating, industrial grade, 3 centimeters of treated titanium alloy. The surface warm now from the drive output. The warmth not yet at the threshold where you would notice it through the soles of your boots, but present, measurable, the first increment of a number that had no ceiling anymore. The AI was watching the temperature. The AI had been told what temperature was acceptable. The AI would not flag it until Vance told it to, which he had not, which meant the flag would never come. Reyes took her hands from the lever. Her eyes moved to the deck plating, to the same section of floor Vance was looking at, and she held there for a moment with the specific quality of attention she brought to things she was computing, rather than simply observing. "The monitoring gap," she said. Not a question. A notation. The verbal equivalent of making a mark in a column, recording a fact that had just been confirmed by direct observation. The microburn had demonstrated it precisely. The AI running clean, the displays showing green, the ship performing actions that should have produced a cascade of critical alerts, and nothing. No color shift, no tone, no pulse from the strobes that were no longer present, no information moving from the state of the systems to the humans responsible for responding to the state of the systems. A gap, clean and absolute, between what was happening and what they would know was happening. They would not know the reactor was melting down until the floor plates began to liquefy. Chapter 5. The Antimatter Weld. The engine room in zero gravity was a different space than the engine room under standard thrust. Under thrust, the room had a floor. It had a ceiling. The heavy equipment, the thruster housing assembly, the fuel line manifolds, the magnetic containment racks, sat in the positions the designers had intended, held there by the same physics that held the crew to the deck. The room had an orientation and a logic and a set of implied rules about where things belonged and how you moved between them. In zero gravity, all of that disappeared. The thruster housing occupied the center of the room, as it always had, but it occupied the center of the room the way a boulder occupies the center of a cave, as a fact of the space rather than a component of a designed arrangement. The fuel line manifolds drifted on their safety tethers, 2 of which had come slightly loose during the drive test, and now moved in slow arcs across the forward bulkhead at the rhythm of whatever micro-vibration the ship's structure was currently conducting. The magnetic containment racks, unbolted from their mounting brackets as part of the modification sequence, were stacked in the aft corner and secured with cargo webbing that Cord had run from 3 separate anchor points to keep them from migrating. They would be needed for reference during the bypass procedure, and then they would be removed entirely. The crew worked in EVA suits, not for vacuum. The compartment was pressurized, had been pressurized throughout the modification process, and the zero-gravity state was artificially induced by cutting the thrust that had been providing the substitute for it, rather than by any exposure to open space. The suits were for the antimatter work. The Mk IV injector arrays operated on magnetic containment that kept the antimatter fuel isolated from any physical contact with non-magnetic material until the moment of controlled injection into the thrust chamber. Removing the containment meant removing the only barrier between the fuel flow and the physical surfaces of the injector housing. At the temperatures and pressures involved in active antimatter flow, the protective value of an EVA suit against direct exposure was approximately theoretical. The suits were not protection, they were procedure, the muscle memory of working around lethal materials in the form of a physical object you put on your body because you had always put it on, and because the action of putting it on organized something in your mind about the nature of what you were about to do. Vance was already inside the thruster housing access panel when the rest of the team arrived. He had gone in ahead to do the initial alignment assessment. The injector mounts needed to be measured against the direct weld configuration before the welding began, because a weld placed at the wrong angle was not correctable. A weld placed at the wrong angle became the permanent geometry of the connection, and the permanent geometry of the connection determined the fuel flow vector, and the fuel flow vector was not a variable. It was the number. Everything else about the modification sequence had tolerances, small ones, but tolerances. The injector weld had none. He had the measurement set done in 18 minutes. The results confirmed the pre-build calculations, which meant either the calculations were right or the measurements were wrong, and Vance had been making these measurements for long enough to know which of those two options was more likely. He came back out of the access panel holding the measurement record and his breath, and found the team suited up and staged in the zero gravity of the engine room, each person oriented to a different surface depending on what handhold they had found. The room therefore occupied in 6 different gravitational directions simultaneously. It looked, in the flat white of the work lamps, like something that should have been disorienting. It was not disorienting. It was just the room. "Alignment is confirmed," he said. His voice came back at him slightly from inside the suit helmet, the specific quality of sound in a sealed space that had no soft surfaces to absorb it. "First weld goes at the primary injector port. Work from the port axis outward. Do not apply pressure to the fuel line before the weld cools." The welder was Thomas, smallest hands on the crew, which mattered when the work surface was the interior of an injector mount housing, and the margin between the weld point and the nearest fuel line coupling was 11 millimeters. In standard gravity, 11 millimeters was narrow. In zero gravity, with the welder's body oriented perpendicular to the work surface and nothing to brace against except a handhold mounted 18 centimeters to the left of the access panel, 11 millimeters was a number that concentrated the mind. Tomas had been briefed. He had practiced the approach on a mock-up in the lower equipment bay for 3 days before the crew entered Sector 4. He moved into the access panel without hesitation, found his handhold, and oriented his body to the work surface with the deliberate slowness of someone who understood that in this specific context, slow and controlled was the only form of fast that did not end everything. The welding torch produced a sound that the EVA suits reduced but did not eliminate. A sustained, high-frequency hiss that conducted through the hull structure and arrived at every person in the room as a vibration in the bones of whatever surface they were in contact with. Not loud, present. The kind of sound that you could not habituate to because it carried too much information about what was happening at its source, and the information it carried was that something very hot was being applied to something that was very close to a fuel line with no containment field between them. Vance positioned himself at the monitoring station he had set up on the aft bulkhead, a basic pressure gauge array pulled from the ship's secondary systems and physically relocated to the engine room for the weld session. The gauges were analog, needle and dial, no digital component, because digital components in proximity to the magnetic field disruption produced by the weld work were unreliable. The needles moved with the pressure fluctuations inside the injector housing in real time, without processing delay, without the possibility of a software error misreading the value and displaying a number that meant the wrong thing. The needles moved and Vance watched them. The breathing in the room was audible. EVA suits compressed ambient sound, but the suits had shared atmosphere monitoring for crew safety, and the crew's breathing was routed through the suit comms at low gain as a secondary safety feature. If someone's breathing changed pattern, if it went fast or shallow or stopped, you heard it. Right now, it was slow and deliberate from every occupied suit in the room, the specific breathing of people who have decided that slow and deliberate is the only appropriate respiratory response to what they are doing. The hiss of the torch, the slow breathing, the faint background hum of the drive core, now drawing above 50% of theoretical maximum and still climbing. the needle on the primary pressure gauge, tracking the internal state of the injector mount in increments that required attention to read. "First weld complete," Thomas said. His voice was flat in the suit comms, stripped of the upper register by the audio compression. "Cooling now, holding position." Vance watched the needle. It was in nominal range, which in this context meant the range he had calculated rather than the range the Bureau had specified, since the Bureau's nominal range did not account for the weld configuration that currently existed inside the injector mount housing. The drive core's autonomous draw was affecting the pressure readings in ways the pre-build calculations had anticipated. Not unpredictably, the fluctuation was within the modeled variance, anticipated, manageable, requiring attention. He watched the needle. Thomas began the second weld. The hiss resumed. The needle on the secondary gauge moved right. A small movement, less than one graduation, the kind of movement that had meaning if you were watching for it and no meaning if you were not. Vance was watching for it. He noted it. He did not say anything because the movement was inside the modeled variance, and saying something would interrupt Thomas's focus on the 11mm gap between the torch tip and the fuel line coupling, and interrupting Thomas's focus on that gap was not something Vance was willing to do for a secondary gauge movement inside modeled variance. The second weld took longer than the first. The geometry of the second port required a different approach angle, which required Thomas to reorient his body on the handhold mid-procedure, a movement he had practiced, that he executed without incident, that nonetheless produced 30 seconds in the middle of the weld, where the torch was paused and the cooling metal was contracting, and the pressure in the injector housing was doing what pressure does in a partially sealed system when a heat source is removed and the metal begins to pull inward. The needle on the secondary gauge moved right again. Further this time, past the modeled variance, still inside the outer tolerance. Vance put his hand on the manual bleed valve and watched the needle. The secondary pressure gauge was monitoring the volume between the injector port seal and the first fuel line coupling, the volume that would contain an active antimatter flow once the welds were complete and the containment was removed. Right now it contained pressurized inert gas, used to test the seal integrity of the completed weld before fuel was ever introduced to the system. The inert gas was at working pressure. If the pressure in that volume exceeded the rated tolerance of the partially completed weld, the weld would breach. If the weld breached under working pressure with inert gas, the corrective action was to bleed the pressure, reposition, and rework. If the weld breached under working pressure with antimatter fuel, which it would not, because fuel would not be introduced until all welds were complete and verified, the corrective action did not exist. The needle held. It held for 11 seconds, inside the outer tolerance, not moving. The pressure in the volume stabilized at the point where the cooling contraction had pushed it and no further. Thomas completed the second weld. The needle retreated to nominal as the weld sealed, and the pressure equilibrated across the new geometry of the joint. The hiss stopped. The breathing in the room continued its slow, deliberate pattern. "Second weld complete," Thomas said. The pressure spike came on the third weld. It was not the weld itself. Thomas had completed the weld cleanly. The seal was sound. The geometry was correct. It was the thermal expansion of the injector housing material as it cooled unevenly, the heat from the weld concentrating in the joint and distributing through the surrounding metal at a rate that the pre-build calculations had modeled, but that the physical reality of the specific alloy composition of this specific housing, an 11-year-old component with its own history of thermal cycling and material fatigue that no pre-build calculation could fully account for, expressed slightly differently than the model had predicted. The pressure in the secondary volume climbed through nominal, climbed through modeled variance, reached the outer tolerance, and kept going. "Bleed," Thomas said. He had not moved his torch. His voice was flat in the comms, the same flat tone he used for everything, and Vance had opened the manual bleed valve before the word was fully out, because he had been watching the needle, and the needle had been telling him this was coming for approximately 4 seconds before the spike reached critical. The bleed valve released pressure from the secondary volume into the ship's internal heatsink network. The secondary thermal management system, not designed for this purpose but capable of absorbing the pressure pulse without damage, which was why Vance had connected the bleed to it rather than to open atmosphere. Raw plasma flowed through the bleed line into the heatsink manifold with a sound that was audible through the hull structure. A brief, low, sustained roar, less than 2 seconds. The sound of high-energy material moving through a conduit that had not been built for it and managing. The needle dropped. The pressure in the secondary volume fell back through the outer tolerance, through modeled variance, back to nominal. The heatsink manifold was now running 20 degrees above its rated operating temperature. Vance noted this. The manifold was not a critical system for the burn. It was a secondary thermal management component, one of the pieces that would have been jettisoned eventually as part of the mass reduction sequence if it had not just become necessary to keep it. The 20-degree elevation would decay over time as the manifold dissipated the absorbed energy. It was manageable. It was a cost. Thomas pulled himself out of the access panel and oriented to the aft bulkhead. His suit read his posture, the set of the shoulders visible even through the EVA layer, as the particular set that meant something had just happened that he was integrating before he said anything about it. Vance checked the pressure gauges in sequence. All needles nominal, all welds sealed. The connection between the Mk IV injectors and the primary thruster housing was now direct and physical and permanent. No magnetic containment field mediating the fuel flow. No electronic buffer between the antimatter and the thrust chamber. No software governor interpreting the pressure readings and making decisions about whether the flow rate was acceptable. A physical valve. A physical seal. A weld. If your hand shakes, Vance said, we don't die. He was looking at the injector housing, not at Thomas. We just cease to have ever existed. Thomas looked at the housing. He looked at the weld seam, the smooth bead of the joint, clean and sound, and the only thing standing between an antimatter fuel flow and the uncontrolled physics of what happened when that flow met an unsealed surface. At the third weld position, 11 millimeters from the nearest fuel line coupling, there was a microfracture. It was small, less than 1/4 of a millimeter across its longest axis, a surface stress fracture in the injector housing material adjacent to the weld heat-affected zone, the kind of fracture that occurred when material with pre-existing fatigue history was exposed to rapid thermal cycling. The weld itself was sound. The fracture was in the housing material, not in the joint. At working pressure with inert gas, the fracture held. Under the thermal and pressure loads of an active antimatter fuel flow at the output levels, the modification was designed to produce, the fracture would be the most stressed point in the entire assembly. Thomas saw it at the same moment Vance's monitoring gauge recorded the pressure anomaly that its presence had produced. A deviation of 0.02 graduations from nominal, barely within instrument resolution. The kind of signal that disappeared into background noise if you were not looking for it, with the specific knowledge that there was something to find. Vance looked at the gauge. He looked at the fracture. He looked at the gauge again. The needle held steady at 0.02 off nominal. It did not move. The margin of error had been erased. What remained was the weld, the fracture, and the distance between them. 1/4 of a millimeter of metal in a piece of hardware that had been sitting in Sector 4 for 11 years, that would be carrying antimatter fuel at working pressure in the near future, that was now the load-bearing point of everything the modification sequence was intended to produce. The calculations had not included it. The calculations had no room for it. The calculations were still correct, and the fracture was still there, and both of those things were true simultaneously, and would remain true for as long as the housing held, which was either long enough or it was not. Chapter 6. Dead weight. The radiation shielding came off in sections. That was the first thing the crew had to accept about the removal process. That something built to be permanent would have to be treated as modular, because the Bureau had not designed the lead composite baffles for removal, and the geometry of the primary bulkhead cavity did not allow a baffle panel to exit the ship as a single unit. The panels were 1.4 meters by 2.2 meters, and they had been installed during the Icarus's original construction, before the exterior hull plating was closed over them, which meant they had spent the ship's entire operational life in a space that had been sealed around them. Getting them out required cutting the mounting brackets, not the baffles themselves, which were composite and would have consumed welding equipment and time, but the steel bracket arms that held each baffle in its cavity position, 3 brackets per panel. Each bracket a 12mm steel rod welded to the primary bulkhead frame at installation and never intended to be touched again. Cord ran the cutting torch. She worked from the forward section aft, 1 bracket at a time, the torch making its specific sound in the bulkhead cavity, a higher pitch than the antimatter weld work, faster, the sound of a tool removing metal rather than joining it. Each bracket separation took approximately 90 seconds. Position, brace, cut, retrieve the separated end before it could migrate. The bulkhead cavity was narrow enough that the torch work required her to orient sideways with her shoulder against the cavity wall, which was not a comfortable position and became less comfortable as the session extended and the cavity retained the heat from the cutting work. She did not adjust her pace. Discomfort was information, and information was useful. And in this case, what the heat in the cavity was telling her was that the work was proceeding and that the metal she was removing had been hot and was now removed, which was the correct sequence of events. The bracket ends fell into the cavity when they separated and had to be retrieved before the panel could move, because a loose bracket end inside a pressurized compartment was a hazard, and cord did not leave hazards behind her. She retrieved each one, set it in the collection bin she had positioned at the cavity mouth, and moved to the next bracket. 3 cuts, retrieve, move. 3 cuts, retrieve, move. The rhythm of work that required precision but not creativity, and that therefore allowed the mind to run its own separate process, while the hands did what the hands knew how to do. She was thinking about mass. The number Reyes had given them, 0.03%, was a function of several variables, and mass was the one Cord had jurisdiction over. Every kilogram removed from the ship was a kilogram that did not have to be accelerated to the velocity the burn required, which meant every kilogram removed was a contribution to the burn curve, which meant every kilogram removed was a small increment of the gap between 0.03 and the extinction boundary closing. The relationship was not linear. The burn curve responded to mass reduction with diminishing returns past a certain threshold, because at relativistic velocity, the relativistic mass curve began to dominate over the rest mass of the vessel, which was why Reyes's calculation had a ceiling on the expected gain from the jettison sequence. But the gain was real. The gain was measurable. The gain was a specific number of additional meters per second at peak velocity, and at the burn profile they were running, every meter per second was load-bearing. She addressed it with the torch. The first panel came free at the forward mount point and tipped into the cavity. 2 of the crew caught it. It weighed 68 kilograms per panel, and in one gravity that weight required 2 people to manage safely in a space with limited maneuvering room. They walked it to the main outer airlock, which Vance had cycled to the dry dock facing position, and they put it through. The airlock was not large enough for the full panel in one orientation. They had to angle it lead edge first and slide it through at 45 degrees, while the second crew member managed the trailing edge. The panel cleared the outer hatch and drifted into the dry dock bay, turning slowly on its long axis in the faint air current from the bay's ventilation system. The second panel followed the first, then the third. By the fourth panel, the rhythm was established and the crew was moving with the specific efficiency of people who have found the physical logic of a task and stopped thinking about it consciously. Cord cut, retrieved, moved. The two-person carry team walked each panel to the lock. The lock cycled. The panel went through. The bay outside accumulated its slow-turning collection of lead composite rectangles, each one identical to the last, each one representing a specific fraction of the ship's total shielded mass that was now outside the ship and staying outside the ship. The bay lighting caught the panels at intervals as they rotated, and the light that came back from them was dull and flat, the non-reflective surface of a material that had been designed to absorb rather than deflect. The last radiation baffle panel cleared the lock hatch at the 3-hour mark. Cord set the torch down and looked at the primary bulkhead cavity. The cavity was empty now in a way that spaces are empty when they have contained something for a long time and the thing has been removed. Not just absent, but visibly absent. The shape of what had been there still legible in the mounting bracket stubs and the 4 contact marks on the cavity floor where the panel feet had rested for decades. She noted it with the same attention she had applied to every other stage of the work, filed it, and picked up the next item on the list. The escape pods were 6 in number, mounted in pairs along the port and starboard access corridors in recessed bay housings that opened to the exterior hull through spring-loaded hatch covers. Each pod was a self-contained survival unit, emergency atmosphere, locator beacon, 6 days of water and compressed nutrition, a medical kit rated for field stabilization of the 3 most common deep space injury profiles, and a basic maneuvering system capable of achieving a stable orbit from any point within the vessel's operational range. The Bureau had required them. The Bureau had specified their placement, their capacity, their maintenance cycle, their accessibility requirements. The Bureau had done this because the Bureau believed, with the weight of 3 centuries of documented incident reports behind it, that the difference between a recoverable situation and an unrecoverable one was frequently the presence of an escape option. The mounting releases were manual, a deliberate redundancy design, ensuring the pods could be deployed even in a total power failure. Twist the collar, pull the handle. The magnetic locks disengaged, and the pod was free of its bay housing. In the intended use case, the crew member deploying the pod would then enter it and trigger the spring-loaded hatch, which would punch the pod clear of the ship on a deployment charge and carry them away from whatever had gone wrong. The Bureau had thought carefully about that moment, the moment a crew member left a damaged ship in a pod, and had designed the system to make it as fast and reliable as possible. In this use case, Vance twisted the collar, pulled the handle, and had 2 crew members maneuver the pod out of its housing and walk it to the main lock. The pods were heavier than they looked. Their survival systems, the atmosphere scrubbers, the water storage, the compressed nutrition packs, the medical kit, the beacon array, were dense components, and the Bureau had not compromised on their quality. Each pod was built to keep a person alive for 6 days under the worst reasonably anticipated conditions, and the mass required to do that was the mass the pod weighed. There was no version of this equipment that was lighter. The Bureau had already found it. The first pod went through the lock and drifted into the dry dock bay to join the radiation panels, its navigation beacon blinking twice on passive mode before the bay's electromagnetic environment suppressed the signal. Then the second. The third pod's housing had a partial weld seam along the collar ring. Maintenance work from the ship's operational period, never recorded in the service log. The kind of informal repair that happened on working vessels when something needed to be addressed and the paperwork was a secondary concern. Cord had to run the torch along the seam before the collar would release. 3 minutes of additional work, a small correction to the sequence, and then the third pod followed the first 2. The 4th, 5th, and 6th went through without incident. 6 pods, 36 days of survival capacity for a crew of 9, at the Bureau's specified emergency ration levels. 247 kilograms of combined mass, calculated against the burn curve, translated into a number that Reyes had computed and delivered to Vance the previous session without emphasis or affect. The way she delivered all numbers, as facts that were what they were regardless of how anyone felt about them. The number was meaningful. The pods were in the dry dock bay. The two things were related, and the relationship between them was that one had produced the other. The crew quarters occupied 4 compartments along the starboard corridor, 2 double-berth sleeping bays, a shared hygiene module, and a small common area that contained the only soft furnishings aboard the Icarus. The Bureau had mandated minimum rest space allocations based on crew size and mission duration, and the designers had met those minimums without exceeding them. Fold-down berths mounted to the bulkheads, restraint systems for zero-gravity sleep periods, 4 fixed chairs bolted to the common area floor, a table surface hinged against the wall. The hygiene module had 2 stations. None of it was structural. All of it was bolted. Vance's team started with the berths, 8 mounting bolts each, extracted with a powered driver. The berths folding flat, and then walked to the lock in stacks of 2. The chair frames followed, the table surface in one piece, the hygiene module after cord capped 2 water feeds and 1 waste line to free it from its plumbing. 12 extra minutes. A slow drip from one fitting that a second cap layer resolved. All of it went through the lock. All of it drifted out into the dry dock bay and joined the constellation of discarded mass already turning in the air current. The radiation panels, the escape pods, and now the berths and chairs and table and hygiene station. The specific catalog of things that made a ship a place where people could live rather than a machine that moved. The distinction between those 2 categories was resolved. The Icarus was the second kind. The medbay was last. It occupied a compartment off the port corridor, adjacent to the forward escape pod housing, sized for the minimum clinical function the Bureau required aboard a vessel of this class. 1 treatment surface, rated for 1 patient at a time. 1 surgical suite, closed and sealed behind its own pressure door, equipped for the 3 procedures the Bureau had determined were most likely to be required in deep space emergency conditions. 1 pharmaceutical storage unit, locked, keyed to Vance's administrative credential by default. 1 diagnostic station, which had never been powered up since the ship entered storage, and which contained, behind its sealed panel, a set of instruments that were precisely calibrated and precisely useless for anything that was going to happen aboard this ship in the near future. Vance stood at the medbay entrance for a moment before the crew began the disconnection sequence. Not hesitating, the decision had been made well before this moment and would not be revisited. He was doing the same thing he had done at every stage of the modification process, taking stock of the thing as it was before it became something different, applying attention to it as an act of record rather than sentiment. The medbay was good engineering. It would have served its function effectively on any voyage it had been designed for. He noted this. Then he stepped back and let the crew work. The medbay was modular by design, a Bureau requirement, enabling field replacement of the entire unit without requiring access to the ship's primary systems. The module disconnected from the corridor structure at 4 junction points, 2 power feeds, and 2 atmospheric circulation connections. Cord's team separated the feeds carefully, not because they needed to preserve the module, but because a poorly separated power feed could arc and damage the corridor's primary circuit. And the corridor's primary circuit was one of the things still aboard and still needed. They capped the circulation connections with the standard blanking plates from the kit and ran a cargo sling under the module's base frame. The module weighed 912 kilograms. It required the full 6-person carry team to move it down the corridor, through the main lock staging area, and into the lock chamber. It did not fit through the lock in one piece. This had been anticipated. Vance had measured the lock aperture against the module dimensions during the initial hull walkthrough and had noted the discrepancy, which was why the kit contained a reciprocating saw rated for the composite material the module's exterior casing was made from. cord cut it in two along the midline. Each half went through separately. The two halves drifted into the dry dock bay and joined the accumulation of panels and pods that was now rotating slowly in the bay's air current. 11 years of careful Bureau-mandated safety architecture, now forming a slow constellation of discarded mass between the Icarus's hull and the bay's far wall. Vance stood at the outer hatch after the second half cleared and looked at what was out there. The dry dock lighting was not generous. Functional industrial floods positioned for visibility during maintenance work, not for observation. But the accumulation was large enough to be visible in that light. The flat rectangles of the radiation panels, the blunt cylinders of the escape pods, the two irregular halves of the medbay module, all of it turning slowly, all of it going nowhere. Everything the Bureau had required the ship to carry in order to be considered safe to operate. Everything the Bureau had specified, debated, mandated, and documented across 3 centuries of accumulated incident reports and design revisions, floating in a dry dock bay in Sector 4, organized by nothing except the faint air current from the ventilation system. None of it was aboard anymore. The ship behind him held the crew, the drive core, the fuel architecture, the antimatter injectors with their 3 completed welds and their microfracture, and the structural frame that Cord had walked on the first day and found specific rather than obsolete. The ship in front of him, floating in pieces in the dry dock bay, held every mechanism the Bureau had ever designed to keep the crew alive if something went wrong. The two things, what was on the ship and what was not, defined each other precisely. Together they constituted the terms of the agreement the crew had made with the universe when they entered Sector 4 and put the bolt in the lock cradle. No radiation shielding, no escape pods, no crew quarters, no medbay, no path back to anything that could be survived by normal means. It was officially a one-way burn. The hull had not groaned under the reduction of mass. It had not shifted in its cradles, or settled, or produced any of the sounds that a structure makes when something significant changes about its load distribution. The Icarus was quieter now than it had been at any point since the work began. The drive core's autonomous draw was the loudest thing aboard, a deep, even pull from 3 decks below that had been present for long enough to have become the new baseline. What had just been removed weighed more than the living crew. The ship was lighter than the people inside it, and it would get lighter still, and the only direction any of the weight was going was out. Chapter 7. Breath for the Burn. The life support system on an Icarus-class vessel was not a single system. That was the first thing the crew learned when Vance unrolled the environmental control schematic on the engineering console and spread it flat under the work lamps. It was a distributed network. Primary oxygen generation in the forward equipment bay, atmospheric circulation routed through a main ducting trunk that ran the full length of the ship's central corridor. Secondary circulation loops branching off the trunk into each compartment, and a thermal exchange subsystem built into the reactor housing that used the ship's life support infrastructure to manage heat flow between the drive core and the external heat sinks. The 3 systems, oxygen generation, atmospheric circulation, and thermal exchange, shared physical infrastructure at 4 junction points, which meant they were not 3 systems in the functional sense, but one system with 3 outputs, and modifying the outputs required modifying the shared infrastructure at its roots. Vance's finger moved to the first junction point on the schematic, then the second, then the third and fourth. We're taking the oxygen output of the primary generation system and routing it directly into the reactor thermal exchange, he said. Not to the crew specifically, to the schematic in the manner of a person working through a process aloud, because the verbalization is part of the process. The exchange currently runs a closed loop using a dedicated coolant fluid. We're replacing the coolant with cryogenic oxygen. The reactor runs hotter than the coolant can manage at the output we're going to ask it to produce. Oxygen runs colder. We need the oxygen where the coolant is, which means the oxygen stops going where it was. A beat in which this resolved itself in the room. "The bridge gets ambient," said one of the engineers in the aft group. "Not a question. The bridge gets whatever partial pressure remains in the ducting after the junction reroute. That's approximately 40% of standard atmospheric oxygen concentration at sea level. Threshold for cognitive impairment is around 60%. We'll be working below that threshold from the moment the reroute goes active." The statement produced no visible response in the room. The crew was past the point where statements of this character produced visible responses. They had been past that point since the bolt went into the lock cradle. What statements of this character produced now was the specific internal recalibration of people adjusting their operational model to incorporate a new constraint, which looked from the outside like nothing. "Rebreathers," said Cord. "Rebreathers," Vance confirmed. He moved to the equipment locker along the starboard bulkhead, one of the lockers they had not jettisoned, because its contents were going to be needed, and opened it. Inside, racked in their charging slots, were 9 high-altitude rebreather units, civilian grade, rated for sustained use at oxygen partial pressures equivalent to approximately 6,000 meters of terrestrial elevation. Not vacuum-rated, not EVA capable, but sufficient for the atmospheric conditions that would exist on the bridge once the reroute was complete. Each unit had a full face mask, a rebreather canister good for approximately 14 hours of continuous use, and a simple digital readout on the canister body showing remaining capacity. He checked the readouts in sequence, all 9 at full charge. He closed the locker and went back to the schematic. The reroute work began in the forward equipment bay, which was where the primary oxygen generation system lived. A rack of electrolytic cells drawing power from the ship's primary circuit and splitting stored water into hydrogen and oxygen. The hydrogen vented to a secondary tank for potential fuel use. The oxygen fed into the main atmospheric trunk. Standard fleet architecture. Reliable. Low maintenance. The kind of system that ran for years without requiring attention, because the Bureau had learned, across decades of deep space operation, that the systems requiring the least attention were the ones the crew would be most likely to still have functioning when they needed them. The crew was going to need it, just not for its intended purpose. Morrell, Environmental Systems, the only engineer on the crew whose entire professional history had been the design and maintenance of life support architecture, opened the forward junction housing and looked at the plumbing with the expression of someone who understood exactly what they were looking at and exactly what was about to happen to it. He had not objected during the schematic briefing. He had not asked questions. He had listened with the particular quality of attention he brought to technical problems, which was total and silent and organized. And then he had picked up his tools and come forward to the junction housing. He had spent 11 years maintaining systems like this one. He understood better than anyone else in the crew what the system was designed to do and how well it did it. He also understood what the reroute would accomplish and why the reroute was necessary. And those two understandings were not in conflict with each other. They were both accurate. The first described a system operating correctly. The second described the same system being reassigned. He disconnected the primary oxygen output line from the atmospheric trunk junction with 2/4 turns of the coupling nut. The line held its internal pressure for a moment after the coupling separated, a soft exhalation of cold, oxygen-rich air that dispersed into the equipment bay atmosphere and was gone in seconds. He capped the trunk side of the junction with a blanking plate, torqued it to spec, and then began the process of extending the rerouted line to the reactor thermal exchange inlet. The extension required new tubing, cryogenic-rated, thick-walled, a material that could manage the thermal differential between the oxygen's cryogenic temperature and the reactor housing's operational heat without embrittling or developing microfractures along the run. They had brought the tubing in the kit specifically for this stage of the modification sequence. Morrell cut lengths, joined sections, fitted the line around the existing infrastructure of the equipment bay without interrupting any of the systems still in active use. The work was deliberate and slow, in the way that plumbing work in tight spaces is always deliberate and slow, and the equipment bay had not been designed with modification access in mind, which meant that every fitting required an approach angle that the bay's architecture was not cooperating with. Cord worked the aft end of the reroute simultaneously, disconnecting the thermal exchange's existing coolant inlet, draining the coolant loop into the collection containers they had staged in the lower engineering deck, cleaning the inlet to accept the oxygen line connection. The coolant was a synthetic fluid, pale blue, specifically formulated for the thermal exchange function it had been performing. It had a faint chemical smell that persisted after draining, the kind of smell that attached itself to surfaces it contacted and took time to dissipate. The lower engineering deck smelled of it for the duration of the reroute work and for some time after. Thomas ran the connection at the midpoint junction, the physical splice that joined Morell's forward run to Cord's aft section, the point where the rerouted oxygen line became a continuous physical path from the generation system to the reactor exchange. The splice fitting required a torque value that Thomas had memorized from the spec sheet rather than carrying the sheet into the tight access space, because the access space did not accommodate both a person and a document simultaneously. He fitted the coupling, applied torque by count of quarter turns rather than by instrument, 12 quarter turns to the specified value for this fitting diameter and wall thickness, and then ran his thumb around the coupling seam in both directions to check for alignment. Clean on both passes. "Ready to pressurize," he said. Vance was at the reactor thermal exchange monitoring station, a set of analog gauges he had relocated to the engineering deck corridor for the reroute session. Same philosophy as the weld monitoring, same reason for choosing analog over digital. He looked at the temperature gauge on the exchange housing. The reactor was drawing at its current autonomous level, generating heat that the existing coolant loop was managing at diminishing efficiency. The coolant had been formulated for the reactor's original operational output, not for the output it was currently producing with the governors removed. The exchange temperature was running elevated. Not critically, the existing coolant had not yet reached its thermal limit, but the trajectory was clear and the timeline was not generous. "Pressurize," he said. Morell opened the valve on the oxygen generation system output. Cryogenic oxygen entered the rerouted line at the generation pressure, cold enough that the line's exterior developed an immediate frost coating along the first meter of run, white and dense, the visual evidence of a temperature differential that the ambient air in the equipment bay had not been prepared for. The frost was not a malfunction, it was physics, the cold surface of the cryogenic line pulling moisture from the warmer ambient air and depositing it as ice crystals along the outer surface of the tubing. It was the same physics that produced condensation on a cold glass, expressed at a lower temperature and a higher density, and it meant the line was functioning as it should. Morell watched the frost spread along the line as the oxygen flow moved forward toward the thermal exchange, the cold front visible from outside the line as a traveling white edge, and he noted it with the attention of someone who had worked around cryogenic systems long enough to know the difference between frost that was expected and frost that was not. This was expected. The needle moved, down. The exchange temperature dropped 20 degrees in the first 40 seconds of oxygen flow, the cryogenic input pulling heat from the reactor housing at a rate the synthetic coolant had not been able to match. The needle continued down, 30 degrees below the pre-reroute reading, 40. The reactor's autonomous draw registered the improved cooling capacity and responded the way ungoverned drive systems respond to improved cooling capacity. It drew more. The drive core's background hum deepened. In the bridge section, separated from the equipment bay and the engineering deck by the central corridor and two bulkhead doors, the atmospheric oxygen concentration began to fall. It was not dramatic. Oxygen partial pressure does not produce dramatic effects at the point of transition. What it produced was subtle and cumulative, a slight increase in the effort required to draw a full breath. a faint awareness at the margins of cognition that something about the operating environment had changed, a narrowing of the comfortable range between the breath you took and the breath you felt you needed. The body noticed before the mind named it, which was how oxygen deprivation always announced itself, through the body's responses rather than through any conscious awareness of the change. Reyes was at the pilot console when the transition crossed the threshold. She was running a systems check on the thrust interface, the same sequence she ran every session, the analog indicators progressing through her field of view left to right, top to bottom. She noticed the change as a mild increase in the effort of the breath she took between the third and fourth gauge in the sequence. Her blood oxygen saturation was, at that moment, approximately 89% of the standard operating range for a person at sea level. 89% was not an emergency. It was a condition. It was the condition that the reroute had been designed to produce, and Reyes had incorporated it into her operational model at the planning stage, which meant she did not need to react to it. She needed to note it and respond appropriately. She noted it, noted its cause, and reached for the rebreather unit she had positioned on the console surface at the start of the session. She fitted the mask, checked the seal with 2 fingers along the edge, and went back to the gauge sequence without breaking her count. The rest of the crew came to their rebreathers in the following minutes, each in the order that the ambient oxygen reached their location's threshold for productive work. There was no announcement. There was no coordinated signal. Each person fitted their mask when the mask became necessary and continued their work. The bridge went from 7 unmasked faces to 7 masked ones over the course of approximately 8 minutes, and the transition looked from the bridge's perspective like a gradual change in the character of the space. Not the emergency gear-up of a crew responding to a crisis, but the quiet, methodical adjustment of people incorporating a new operational constraint into an ongoing task. Nothing was wrong. The engine needed the oxygen. The masks supplied the rest. That was the arrangement, and the arrangement was functioning. The rebreather canisters hissed faintly with each breath cycle. It was a soft sound, rhythmic, the sound of the units doing their function. Under it, the ventilation fans ran their standard cycle, moving air that now contained less oxygen through the ducting at the same rate they always had, because the fans did not know the composition of the air they were moving and did not adjust for it. The ducting carried what it carried. The fans moved it. The crew breathed the rest. Vance came up from the engineering deck to the bridge after confirming the exchange temperature had stabilized at its new operating point, 61 degrees below the pre-reroute level, holding steady, the reactor drawing against the improved cooling and the oxygen supply keeping pace. He fitted his rebreather in the corridor before entering the bridge, the automatic response of a person who had planned this stage in enough detail to know what he was going to find on the other side of the bulkhead door. He looked at the crew at their stations, masks on, canisters reading in the green of their capacity displays, the bridge carrying out its functions at the same pace and precision it had maintained throughout the modification sequence. He looked at the thermal exchange readout he had brought up on the AI monitoring feed. The new operating temperature, stable, the reactor running at a sustained output level that the previous coolant architecture would not have been able to support. The engine was breathing the oxygen. The crew was breathing the canisters. The arrangement was explicit and permanent, and had been decided the moment the reroute valve opened and the cryogenic oxygen took the path it had been given. "The engine needs to breathe more than we do," Vance said. Nobody disagreed with that. The rebreather canisters hissed their soft, rhythmic confirmation with each breath drawn through each mask in the room. 14 hours of capacity per unit. The burn sequence was not scheduled to begin within 14 hours. The canisters would need to be rotated before ignition. That was a logistics problem with a logistics solution, and logistics problems with logistics solutions were the manageable category, which meant this one was already resolved in Vance's operational model and did not require further attention. What required attention was the exchange temperature, which was stable, and the reactor draw, which was not. Chapter 8. The Unauthorized Overclock. The first pressurized test of the direct-weld injector sequence had been scheduled for 0600 station time, which was a fiction. There was no station time anymore. There was no connection to the station's chronometer system, no network sync, no external reference for the progression of hours that the crew's biology continued to track regardless of what the ship's systems did or did not report. What the 0600 marker meant in practice was that Vance had looked at the rebreather canister readout on his mask, noted that it had been running for 9 hours since the last rotation, and decided that 9 hours was a sufficient rest interval between the completion of the oxygen reroute and the beginning of the ignition sequence. He had made this decision with the same economy he brought to all decisions at this stage. Quickly, based on the information available, without revisiting it. The crew assembled on the bridge at the time Vance had specified without being reminded. Reyes was already at the pilot console. She had been there for 40 minutes before anyone else arrived, running the analog indicators in their sequence, left to right, top to bottom, her rebreather canister hissing its soft rhythm against the background of the ventilation fans. She had the drive interface readings mapped against the projections she had built before the modification sequence began. The projections that had started with the anomaly data and the certified options velocity spread, and the single word she had written at the bottom of the display, and had expanded from there into the operational model that now existed in her head as a precise and continuously updated set of numbers. The drive core was drawing at 61% of theoretical maximum on its autonomous feed. That was higher than the projection had anticipated at this stage. She had updated the projection. The update was not favorable, in the sense that the margin it described was narrower than the margin the previous version had described. It was accurate, in the sense that accuracy was the only quality a projection was required to have. The analog indicators completed their sequence. She ran them again. The second pass confirmed the first pass, which was what a second pass was for, not because she had doubted the first pass, but because the operating principle that had produced the first pass required a second pass, and the principle did not make exceptions for the quality of the first pass. When the second pass confirmed, she noted the drive core reading, updated the projection by the increment that the new reading required, and held the updated figure in the place in her operational model where the burn margin lived. The margin was narrower than it had been. It was not zero. Those were the two facts that mattered, and they were both accurate, and she noted them and kept watching the gauges. Vance primed the injector sequence from the engineering console. The priming procedure was the series of valve positions and pressure settings that prepared the direct-weld injector array for its first live fuel exposure. The configuration that the weld geometry and the pressure tolerances of the modified assembly required before antimatter could be introduced to the system. He had run the procedure in his head several hundred times across the preparation period. He had rehearsed the valve sequence until it lived in the hands rather than the reasoning brain. The kind of knowledge that did not require active recall under pressure. Running it on the physical hardware took 11 minutes. The hardware responded correctly at each step. At the end of the 11 minutes, the pressure gauges on the injector monitoring array, analog, same reason as before, showed the modified assembly in the configuration that the pre-build calculations had specified as the correct pre-ignition state. All gauges nominal. The microfracture at the third weld position was showing 0.02 off nominal on the secondary pressure gauge, the same reading it had shown since Tomas had found it during the weld session. The reading had not increased. Vance noted this with the particular quality of attention that stable anomalies deserved. Not the attention you gave to a problem that was changing and therefore required immediate response, but the attention you gave to a problem that was not changing and therefore required continuous monitoring. Stable was not the same as resolved. Stable was the state the fracture was currently in. The burn was the test that would determine whether those two things were going to turn out to mean the same thing or different things, and the distinction mattered in ways that no gauge could currently measure, because the gauge could only tell you what the fracture was doing now, and now was not the burn. "Injectors primed," he said. "Thrust interface ready," Reyes said. Her eyes had not left the analog array. "Drive core at 61% autonomous draw. Mooring clamp status, 4 active, rated to current load." A pause the exact length of one reading. "The clamps are not rated to the load we are about to produce." "I know." "Noted." She did not look at the clamp gauges. The gauges were already in her operational model. The rated load, the current draw, the delta between the two, the structural tolerance of the cradle attachment architecture at the force levels the test was going to produce. She had computed it. The number was what it was. She wrapped both hands around the primary thrust lever and positioned her feet against the crash couch base frame, the brace that the Bureau had built into the couch for exactly the kind of high-output event that was approximately 30 seconds away. The hull was quiet in the way it had been quiet since the alarm array came out. The ventilation hum, the processing stack hum from below, the soft rhythm of rebreather canisters, and underneath all of it the deepening draw of the drive core, present and patient and growing. The work lamps threw their flat white light across the bridge consoles. The AI terminal showed green on every monitored system. The analog gauges on the injector array held their readings. The mooring clamps held the ship in its cradles with the patient indifference of infrastructure that had been asked to hold still and was still holding. The dry dock bay outside the sealed blast door was quiet too, in a way that was different from the ship's quiet. The ship's quiet was the quiet of systems running, things in motion, things under load, things producing output at various levels, the accumulated background of an operational machine in the process of becoming something more than it had been designed to be. The dry dock bay's quiet was the quiet of a space that contained the discarded mass of the ship's former safety architecture and nothing else. The radiation panels were still turning slowly in the air current, the same slow arcs they had been describing since they went through the lock. The escape pods were drifting in their measured rotations, the beacon on the first pod still blinking twice on passive mode and failing each time to raise anything because there was nothing in the bay to raise. The berths and chairs in medbay sections were still suspended in the positions they had occupied since they were put through the lock. The furniture of a place where people could have lived floating in the cold of a sealed bay that had not been designed for storage and was not going to be used for storage for long. Everything out there was going nowhere. The Icarus was going to leave it all behind. The bay would hold all of it long after the Icarus was past the range where any of those distinctions had meaning. Vance looked at the injector pressure array one more time. He looked at the microfracture reading. He looked at Reyes's hands on the lever. "Prime," he said. Reyes broke the detent. The force required to break it was higher than it had been during the micro-burn test, and she had known it would be higher, and she had applied the additional force in the same smooth, deliberate movement she applied to everything at the controls. Not faster than necessary, not slower, exactly the speed that the action required, and no other. The detent released. The sound it produced when it released under the direct-weld injector load was not the same sound it had produced during the micro-burn test. The micro-burn test had been a 15% lever position with the injectors running in their standard containment configuration. This was the full direct-weld array at the pre-ignition pressure setting, which meant the lever's resistance profile across the arc from rest to the test position was different in a way that communicated itself immediately through the hands on the lever, heavier, with a quality of loading that the microburn's resistance profile had not contained. Not unmanageable. Different. Reyes noted the difference without adjusting her pace and advanced the lever to the test position. The hull began to groan. It was not the subtle, low-threshold creak of the thermal flex that the crew had been hearing since the first day in the bay. It was a structural sound, A full register acoustic event produced by a mass of several thousand tons receiving a force load that its cradle-mounting architecture had not been designed to accommodate. The sound traveled through the deck plating from the mooring clamp attachment points, through the primary frame members, through the secondary bulkheads, arriving at the bridge as a deep sustained resonance that occupied the lower registers of hearing and the upper registers of physical sensation simultaneously. You heard it and felt it as a single event, the way you hear and feel thunder, the sound and the physical force arriving together from the same source, so that distinguishing between the two required more analytical effort than the situation left room for. The consoles vibrated, not the instrument face rattle of the microburn, but a sustained, full-amplitude vibration that moved every loose surface in the room and made the act of reading the gauges an exercise in holding your vision stable against a background that was not. The monitoring schematics Vance had laid on the console surface began their slide toward the edge. The work lamp on its mounting cable described its pendulum arc, slow at first and then wider as the resonance sustained. The cable housing flex allowing more travel than it had been rated for. The air in the bridge moved, not from the ventilation system, but from the acoustic pressure of the structural resonance propagating through the atmosphere of the room itself. A sensation of the air having weight and direction that the engineering data did not fully prepare you for, even when you had read the engineering data carefully and understood what it meant. The mooring clamp status indicators showed their readings. The first clamp was at 112% of rated capacity. The second was at 119. The third was at 124. The fourth was climbing. All three released in the same instant. Not sequential, simultaneous. A single acoustic event arriving through the hull as a triple crack compressed into a fraction of a second. 3 points of failure resolving at once as the load exceeded their combined rated capacity in the same moment. The sound reached the bridge through the hull structure before it reached the bridge through the air, the solid metal pathway faster than atmosphere, so that the crew felt the failure in the deck beneath their boots before their ears had fully resolved the crack into a discrete sound. The ship tore from its cradles on three sides and drove hard against the fourth clamp, the only one still holding. The force of several thousand tons of unrestrained vessel transferred into a single mooring point in a single instant. The lateral movement was violent, a full, hard translation of the entire hull mass against the surviving clamp and the dry dock superstructure behind it. Nothing gradual about it, nothing that gave the frame time to distribute the load. The frame had been built for vessels in maintenance configuration, static loads, controlled environments, the patient weight of ships at rest. It had not been built for this. It had no specification for this. It had no failure mode designed for graceful degradation under this class of input, because the class of input had not existed until 30 seconds ago when Reyes broke the detent. What the frame had was the material properties of heavy industrial titanium, the structural geometry of its assembly, and the physics of what happens when both of those things are asked to do something they were never designed to do. The frame did not distribute it. It received it. The dry dock superstructure buckled. The sound it produced was not like the clamp failures. It was lower and larger, a sound with mass, a deep sustained report that came through the hull from the bay's own frame, the acoustic signature of heavy industrial titanium yielding under a load that it had not been designed to meet and could not refuse. It lasted approximately 2 seconds, which was the time it took for the frame to complete its deformation and reach the geometry it would now permanently occupy. At the end of those 2 seconds, the structure was in a new shape, and the new shape would not reverse, and the force that had produced it was 1 second of test output at a fraction of the full burn capacity. Reyes pulled the lever to rest without being told. The drive output fell, fast at first, and then trailing off through the lower registers, the acoustic profile of the hull descent matching the ascent in reverse. The resonance dropping through its frequencies in sequence, each register falling quiet in the order it had arrived, until the bridge returned to its standard ambient. Ventilation fans, processing stack hum, rebreather canisters. The hull resonance faded through its registers and stilled. The fourth clamp held, bent, its geometry permanently altered by the lateral force it had absorbed in approximately 1 second, but holding, the ship resting against it at an angle the cradle architecture had never been designed to accommodate and was now going to accommodate indefinitely. Vance looked at the injector pressure array. All gauges nominal, the microfracture reading, 0.02 off nominal, unchanged. He pulled the rebreather mask down from his face, drew 1 breath of the bridge air. Thin, 40% concentration, the specific quality of air that communicated its insufficiency as a mild constriction in the chest, a narrowing between the breath taken and the breath needed, the biology registering the deficit without requiring the mind to explain it, and put the mask back. "We aren't flying it anymore," he said. He was looking at the injector array, not at Reyes, not at the crew, at the gauges, at the reading that was 2 off nominal and unchanged. "We're just riding the explosion." Chapter 9, The Point of Ignition. The security alert reached the station's duty officer at 0917. It arrived as a flag on the automated monitoring feed. Sector 4 Bay. Sealed, unauthorized occupancy duration exceeding 72 hours. Acoustic anomaly registered in the bay's passive structural monitoring array. External communications from the bay's interior attempting and failing to reach the station network on 6 consecutive attempts over the preceding 18 hours. The duty officer pulled the flag, read the attached data, and spent approximately 40 seconds understanding what the data meant before she reached for the emergency contact line to the station's security division. She was not slow. She was methodical, which was a different thing, and the methodical reading of the data had produced a picture that the methodical reading of the data required her to act on. The security team assembled in 12 minutes. 14 officers, full tactical loadout, the heavy door breaching kit that lived in the security bay's equipment locker and had not been used in 11 years, which was how long the locker had been collecting its particular layer of dust on the equipment surfaces, and which was also how long Sector 4 had been sealed, and which was not a coincidence that anyone on the security team had the context to notice. They moved through the station's maintenance corridor toward the Sector 4 access hatch with the specific efficiency of people who had been trained to move in exactly this configuration toward exactly this class of situation, which was sealed unauthorized access, unknown occupant count, unknown capability, acoustic evidence of mechanical activity, significant enough to register on passive structural monitoring at 2 corridor sections of distance. What the passive structural monitoring had registered was, in fact, the direct-weld ignition test. What the passive structural monitoring had not been designed to register, and therefore had not flagged alongside the acoustic anomaly, was the current state of the dry dock bay. The 3 failed mooring clamps, the permanently buckled section of the bay's titanium superstructure, the constellation of jettisoned safety equipment still turning in the bay's air current, and the Icarus-class hull listing at an angle against its single remaining functional cradle mounting point, with its drive core drawing at 68% of theoretical maximum and climbing. The passive monitoring system reported acoustic events. It did not report context. Context was what the security team was walking toward to acquire. They reached the outer access corridor of Sector 4 at 0941. The security team's breach specialist assessed the access hatch, the same bolt lock that Vance had installed from the inside 72 hours prior, and began the physical bypass procedure. The bypass procedure for a manual bolt lock of this type required access to the hatch's internal mechanism through the access panel on the corridor side, which required the removal of the access panel cover, which required a tool that the breach kit contained and that the specialist retrieved and applied. The procedure was not fast. It was designed to be reliable, not fast, on the principle that a reliable procedure could eventually succeed where a fast but unreliable procedure might fail at the worst possible moment. The specialist estimated 3 minutes. The duty officer, who had come to observe, noted the estimate and reached for her communications unit to report a timeline. On the bridge of the Icarus, the security alert arrived as a sound. Not the alarm array, that was gone, its wiring coiled neatly in the junction boxes of each compartment, going nowhere. The sound was physical, a series of rhythmic metallic impacts from the direction of the outer access hatch transmitted through the hull structure and arriving at the bridge as a sequence of faint percussions in the deck plating, barely audible above the drive core's baseline draw and the ventilation fans and the rebreather canisters. Barely audible was sufficient. The bridge had been quiet enough for long enough that any addition to its acoustic environment registered. Reyes heard it first. Her eyes moved to Vance. He had already heard it. He was at the engineering console, the injector pressure array in his direct sight line, the analog gauges showing what they had been showing, nominal across all primary readings, 0.02 off on the secondary, unchanged. He looked at the gauges for one more second. Then he looked at Reyes. "What's the status on the last clamp?" he said. "Bent. Load capacity reduced to approximately 40% of rated. Still attached." She had run the assessment during the hours since the test burn. The same continuous operational update she applied to every system in her model. "It will not survive full thrust output. It doesn't have to." She looked at him with the quality of attention she brought to statements that contained more information than their surface indicated. The clamp did not have to survive full thrust output because full thrust output would remove the ship from the clamp's jurisdiction entirely. Would take the Icarus from a moored vessel to an unmoored one in a time interval shorter than the clamp's structural failure sequence could complete. The clamp would fail, but the ship would already be gone when it did, and the clamp's failure mode was therefore irrelevant. She had already run this calculation. She was confirming that Vance had run it too, which he had, which was what the exchange had established. She put both hands on the primary thrust lever. The metallic impacts from the hatch continued. Vance could hear them resolving, not faster but closer in the sense of closer to completion, the specific rhythm of a bypass procedure progressing through its steps. He did not have the procedure's timeline. He had a sound, and the sound had a character, and the character said he had minutes rather than seconds. He looked at the crew. The crew was already at their stations, every rebreather canister showing capacity in the functional range. Every person positioned for the event that had been the operational endpoint of everything done in this bay since the bolt went into the lock cradle. Nobody was looking at the hatch. Nobody was looking anywhere except at the work in front of them, because there was no other direction that was useful. Vance looked at the remaining mooring clamp status gauge. He looked at the injector pressure array. He looked at the microfracture reading, 0.02, unchanged. He put his rebreather mask back on, checked the seal, and went to his position at the engineering console. Outside in the station's maintenance corridor, the breach specialist completed the third stage of the bypass procedure. The access panel cover was off. The internal mechanism was exposed. The tool was engaged on the bolt release cam. 2 more steps. Rotate the cam, retract the bolt. The specialist began the rotation. Vance said, "Full thrust." Reyes broke the detent. The difference between the test burn and the full burn was not a matter of degree. It was a matter of category. The test burn had been the throttle at a fraction of the lever's arc, the drive core receiving a fraction of the command it was capable of receiving, producing a fraction of the output it was built to produce. The full burn was the lever advanced in a single continuous movement from rest to maximum, the detent cracking on the first motion and the lever traveling the full arc in approximately 1 second, the drive core receiving the complete command across the full range of the injector array's modified output capacity in the same interval. The hull did not groan this time. It screamed. The sound was different in kind from anything the ship had produced during the modification sequence. Not the resonance of a structure under load, not the creak of thermal flex, not the bass rumble of the test burn's acoustic signature traveling through deck plating. This was a full-spectrum acoustic event. Every frequency of the ship's structural voice activated simultaneously. The titanium of the primary spine and the secondary bulkheads and the tertiary frame members all contributing their individual resonances to a combined output that the human auditory system processed as a single overwhelming sound. It occupied the chest and the skull and the boots and the palms simultaneously. It was the sound of the Icarus discovering what it could do. The remaining mooring clamp failed in the first half-second. The dry dock bay's second structural failure was not the same as the first. The first had been concentrated. The buckle of the test burn's force channeled through 3 simultaneous clamp releases into the bay frame at a specific point. This was distributed. The exhaust wash from the direct-weld injectors at full thrust output hit the rear wall of the dry dock bay. The cradle architecture, the floating constellation of jettisoned safety equipment, and the bay's full structural perimeter simultaneously. A pressure wave of thermal and acoustic energy expanding outward from the Icarus's aft section in all directions at once. The bay was not built for this. No bay was built for this. The rear wall received the exhaust wash first, and the rear wall's response was not gradual. On the other side of the outer access hatch, the breach specialist had completed the cam rotation and was beginning the bolt retraction. The Icarus was no longer in the bay. It was in the station's maintenance corridor for approximately 1/10 of a second. Not physically, but acoustically. The pressure wave of the full burn exhaust propagating outward through every structural connection between the dry dock bay and the surrounding station infrastructure, arriving at walls and conduits and the hatch itself and the corridor beyond the hatch as a single, simultaneous physical event. The hatch held. The station's structural architecture was built for significant pressure loads. What the corridor on the other side of the hatch experienced was not the exhaust wash directly, but its echo, attenuated through the hatch material, sufficient to knock the breach specialist backward 2 steps and to register on the station's structural monitoring as a pressure event of the second highest recorded magnitude in the station's operational history. The security team did not breach the hatch. The Icarus was in open space at the point where this became irrelevant. The transition from the dry dock bay to open space was not smooth. The Icarus exited through the bay's external aperture, the maintenance access opening that the dry dock used for vessel ingress and egress, at a velocity and trajectory that the aperture's geometry had not been designed to accommodate at that velocity and in that trajectory. The ship's hull made contact with the aperture's frame on the port side. The contact lasted approximately 40 milliseconds and produced a structural mark along the port bow section that would have been a catastrophic impact at any lower relative velocity, and was, at this velocity, an incidental friction event. The hull moving faster than the frame's material could respond to the contact therefore producing a long scrape rather than a collision. The mark was permanent. The hull did not care. The G-force arrived with the open space. Inside the bay, the drive core's exhaust had been partially constrained by the bay's architecture. The walls, the ceiling, the floor, all of them reflecting exhaust energy back toward the ship in a pattern that partially canceled the thrust vector's effect on the crew's bodies. In open space, there was nothing to reflect anything. The full thrust vector applied itself to the crew without mediation. The crash couches absorbed a significant fraction of the load through their designed deformation response. The fraction they did not absorb applied itself to the crew directly, at a magnitude that compressed the chest, narrowed the visual field at the periphery, and made the act of maintaining a grip on anything requiring both the intention to maintain the grip and a physical effort proportional to the weight of the thing being held, multiplied by the G-load being applied to it. Reyes maintained her grip on the thrust lever. She maintained it because her hands had been positioned on the lever before the detent broke and had not been repositioned since, and because the crash couch's restraint system was holding her body in the position her hands needed to be in to stay on the lever, And because she had known this was going to happen and had prepared her body for it, with the same precision she brought to every calculation, she could not move her head easily. She could not turn toward the gauges on her left without a sustained physical effort that the G-load made expensive. She kept her eyes on the primary thrust indicator, which was the gauge directly in front of her crash couch, which was showing maximum output, which was showing it correctly. The navigation displays were mounted on the upper section of the forward bulkhead, above the primary viewport, visible to the bridge crew during normal operations as the primary reference for positional data. They were mounted there because the Bureau had specified their position, and the Bureau had specified their position for the same reason the Bureau specified everything, because the position made operational sense under the conditions the Bureau had designed the ship to operate in. The conditions the Bureau had designed the ship to operate in did not include full thrust at modified direct-weld injector output from a standing start inside a dry dock bay after a portside hull contact with the bay aperture frame. The navigation displays were analog-backed with digital overlay panels. The digital overlay panels were mounted to the analog housings with 4 fasteners each, rated for the vibration loads of standard operational burn. The vibration load of the full burn was not the vibration load of standard operational burn. The first display's overlay panel separated from its housing at the left side upper fastener, the fastener shearing, the panel tilting at a 45-degree angle, and then completing its separation as the remaining 3 fasteners followed in cascade. The panel hit the forward bulkhead. The second display's overlay separated 2 seconds later. Same failure mode, same result. The third and fourth went simultaneously, a paired failure, their panels crossing each other's trajectory as they left their housings and meeting the bulkhead in the same instant with a sound that was swallowed entirely by the larger acoustic environment of the full burn. The navigation displays were dark. The Icarus was accelerating blind into the void on a vector Reyes had computed before the bolt went into the lock cradle, toward a boundary that had been expanding at a rate the certified options could not match, at a speed that nothing certified had ever been asked to produce. The gauges in front of Reyes showed maximum output. The gauges did not show where they were. Nobody on the bridge was going to be able to tell them that either. Chapter 10. The Sublight Barrier. The first thing that changed was the light. Not the light inside the ship. The work lamps were still running, the AI terminal still showing its flat, uninflected green, the analog gauges still lit by their individual dial lamps in the orange-amber of instruments designed for low-light operational conditions. The interior of the Icarus had not changed. What changed was the light coming in through the primary viewport, the narrow strip of reinforced glass set into the forward bulkhead at pilot console height, 40 centimeters wide and 12 tall, rated for micrometeorite impact and laser dispersal and the thermal stress of sustained orbital operations, and nothing else, because nothing else had been expected to be required. The stars outside the viewport were moving. That was not unusual. Stars had been moving since the moment the Icarus cleared the dry dock aperture. Had been moving because the ship was moving, the visual field shifting as any vessel's visual field shifts under acceleration. What was unusual was the quality of the motion. Under normal acceleration, the stars moved the way objects move when observed from a moving platform. Smoothly, at rates proportional to their angular distance from the direction of travel, near objects faster and far objects slower, the parallax of relative velocity. This was not that. The stars at the outer edge of the viewport were beginning to describe arcs, not smooth and proportional, but elongated, the light of each star smearing along its trajectory as though the exposure time of the universe had been extended beyond the point where a point source of light remained a point. Reyes watched the viewport without moving her head. Moving her head was expensive under the current G-load, not impossible, not beyond the limit of what her body could produce, but a deliberate expenditure of physical effort that she allocated against the return value of the information gained. The viewport was in her direct sightline from the crash couch. She watched it without cost. 0.68, she said. Not a question, not a report to anyone specifically. A notation, the same as always. The verbal equivalent of writing a number in a column. The velocity relative to light speed, derived from the thrust output readings on her primary gauge and the elapsed burn time she was tracking against the internal count she had been running since the moment the detent broke. She did not have navigation. She had physics, which was more reliable than navigation in the specific sense that physics did not require functioning hardware, and in the additional sense that the number physics gave her was the true number, derived from first principles rather than from a display panel that could be damaged, or a software system that could be reset. Physics gave you what was actually happening. She was reporting what was actually happening. The hull had been talking since the dry dock. Not the thermal flex creak of the modification period or the structural resonance of the test burn, but a new register, a sustained, layered acoustic signature that occupied the lower half of human hearing and the upper half of physical sensation. The sound of a titanium frame moving through space at a velocity for which its designers had not specified a performance envelope. The spine was flexing, not failing. The Icarus-class distributed stress rather than concentrating it, which was the characteristic that had made it specific rather than obsolete. And the distribution was happening now across the full length of the 87-meter frame as the relativistic pressure built against the forward surfaces and propagated backward through the girder structure. Each primary rib junction was taking its share. The share was survivable. The sound it produced while surviving was the sound the ship was making. It was a sound the universe had never made before. The structural integrity field, the electromagnetic system that supplemented the physical frame's load-bearing capacity by maintaining a shaped field around the hull's exterior, had been running since the dry dock departure at its standard output level. Standard output level was calibrated for standard operational conditions, which were not these conditions. At 0.68 of light speed, the field's shape geometry was encountering the photon pressure and particle flux of relativistic travel, and the encounter was not clean. The field flickered. Not a failure, not a dropout. A flicker, the field's control system attempting to maintain its calibrated shape against inputs it had not been designed to manage, succeeding on each individual cycle and producing a visible effect across the hull's exterior that the crew could not see, but that the structural monitoring feeds were reporting as a periodic variation in field integrity. Periodic variation in field integrity was the technical language for what the bridge crew was experiencing as a pulse. Every 4 to 5 seconds, the field's flicker produced a corresponding event in the hull's behavior. A brief reduction in the electromagnetic supplementation of the frame's load capacity, lasting approximately half a second, during which the full relativistic load was carried by the physical titanium alone. During those half seconds, the hull's acoustic signature changed. It deepened. The sound dropped through its registers into a range that the human auditory system classified as felt rather than heard, and the classification was accurate. During the field's flicker intervals, the sound was present in the chest and the seat of the crash couch and the deck plating rather than in the ears, a physical event rather than an acoustic one. Then the field restabilized and the register returned, and the cycle continued at its 4 to 5 second interval. Vance had identified the flicker pattern within the first 3 minutes of open space burn. He was tracking it on the structural integrity monitoring feed, one of the feeds the AI was maintaining, the numbers flowing across the display and the flat, even cadence of a system performing its observation function correctly and having no opinion about what it was observing. He watched the numbers through the flicker cycles and noted the interval and noted the magnitude and ran the calculation that the interval and magnitude required. The field was sustainable at this output. It was sustainable at the current velocity. What the calculation could not tell him was whether it would remain sustainable as the velocity increased. The field's calibration parameters had not been tested at relativistic speeds because no vessel had previously operated at relativistic speeds with this configuration, and untested parameters had a specific epistemological status in Vance's operational model. They were not known. They were projected. The projection said sustainable. The projection was built on the same physics that said the hull would distribute rather than concentrate the load, and that physics had been right about the hull. And he had no better number than the projection's number. And the projection's number was not the kind of number you stopped for. 0.74, Reyes said. The star traces in the viewport had lengthened. They were no longer arcs. They were lines. Each star's light drawn out from its source position along the direction of travel into a streak that had a distinct beginning and a trailing edge that blurred rather than terminated. The field of view through the viewport was transitioning from a display of discrete light sources to something that was beginning to resemble a solid structure, the individual streaks overlapping and blending at the outer edges of the aperture into a continuous luminous field. The sky outside the Icarus was no longer a distribution of points. It was becoming something else, something that had no established term in the vocabulary of navigation or astronomy because nothing had ever moved fast enough to see it. The bulkheads moved. This was not the hull's acoustic signature. This was visible, a slow rhythmic compression and extension of the portside secondary bulkhead, the panel surface moving in and out from its mounted position by approximately 2 millimeters at the cycle's extremes, the motion synchronized with the structural integrity field's flicker interval. 2 millimeters was not catastrophic. 2 millimeters was the frame distributing its load across the panel's surface, the titanium behaving as a slightly elastic material under sustained relativistic stress rather than as the rigid structure it was certified to be. And the behavior was within the calculated tolerance for the Icarus-class spine under these projected load conditions. Calculated tolerance meant the calculation had predicted this. Seeing the bulkhead move was confirmation that the calculation was correct. Cord, in the aft section of the bridge monitoring the secondary structural feeds, watched the bulkhead move and noted the amplitude without looking away from her gauges. She had seen the calculation. She had seen the projected tolerance range. The amplitude was inside it. She noted it and watched the next cycle. 0.81, Reyes said. Her voice had not changed register across the three readings. The same flat delivery, the same precision, the same absence of anything that would indicate that the number she had just said was a number that no crewed vessel had previously reported in an operational log. She was aware that it was that number. The awareness produced the same internal response that all accurate information produced in her operational model. Incorporation, update, continued monitoring. The number was what it was. It meant what it meant. She kept her eyes on the gauges and let it mean it. The G-load on the crew was crushing in the technical sense. The crash couches were managing it, the restraint systems were managing it. The crew's bodies were absorbing the residual fraction that the couches did not manage, and the residual fraction was within the range that trained operators could sustain for the required duration without losing the capacity to function. Sustain was the operative word. Not comfortable, not tolerable in the sense of undemanding, survivable across the burn window, which was what the burn required, which was what the calculation had been built to produce. The vision blur that the Bible specified for this velocity range was present. Not dramatic, not a blackout, not a loss of consciousness, not anything that produced a gap in awareness. A softening of the periphery, the outer edges of the visual field losing definition, the sharpness of objects at the margin of vision reducing to a quality that registered as movement even when the objects were stationary. The brain interpreting the blur as motion because blur at the visual periphery was how motion had presented itself throughout the evolutionary history of the visual system, and the visual system had no other category for it. Reyes's peripheral vision was blurred. The gauges directly in front of her were not. She read the gauges. 0.89, she said. Vance looked at her from the engineering console. The number she had just said was larger than any number a crewed vessel had registered under thrust in the documented history of space travel, It was larger by a margin that made the previous record not a predecessor, but a different category of event entirely. He was aware of this. She was aware of this. The crew was aware of this. The awareness produced, in the bridge of the Icarus at this moment, no observable effect. Not because it had no significance, but because significance and operational response were different things, and the operational response to the number was to keep the gauges in sight line and the hands where they needed to be and the rebreather canisters cycling, which was what everyone was already doing. The structural integrity field flickered. In the half-second of its dropout, the hull's acoustic register dropped, felt rather than heard, the full relativistic load on the titanium spine producing the specific frequency that the primary rib junctions generated when they were distributing maximum stress simultaneously across the full frame length. The third rib junction from the aft compartment, the one Reyes had identified on the first walkthrough, the one Vance had felt and noted, produced a sound in that half-second that was distinct from the surrounding acoustic field. Not louder, more specific. The sound of a junction that was carrying its full share of the load and communicating the fact of it in the language that the frame used for communication. A deep, resonant, specific note that lasted exactly as long as the field's dropout and ceased the moment the field restabilized. Then it happened. The transition was not announced. It did not produce a moment of silence or a sudden change in the quality of the environment that signaled itself as a threshold crossing. It was a physical event that occurred and was recognized only by its effects, which arrived simultaneously across every surface of the ship at once. The G-load changed quality, the acoustic signature changed register, the visual field outside the viewport reorganized itself from streaks into something that language had not previously been required to describe. The star traces did not lengthen further. They disappeared. What replaced them was a uniform, blinding field of compressed light. Not white exactly, not any color that existed in the standard spectrum. A frequency of electromagnetic energy that the viewport's reinforced glass was transmitting and the human visual system was receiving as an intensity rather than a color. A brightness that required no adaptation time because the visual system had no adaptation category for it, only a direct signal of overwhelming luminous input that the brain logged as seen without being able to specify what was being seen. The Icarus had violently punched through the theoretical sublight barrier, rewriting physics. The gauges continued to register. The AI continued to observe. The rebreather canisters hissed their rhythmic confirmation with each breath drawn through each mask on the bridge, 9 soft percussion beats at 9 different intervals. The biological proof that the crew was still present and still breathing on the other side of a threshold that the Bureau's engineering specifications did not contain a tolerance rating for, because the Bureau had never needed one. Vance looked at the blinding field in the viewport. He looked at the gauges. He looked at the frame member above the engineering console, the primary spine girder, carrying its share of the relativistic load the way it had been built to carry load, distributed, methodical, without complaint. Physics is just a suggestion, he said, once you have enough thrust. Outside the viewport, the galaxy was doing something it had not done before. The crew had made it do something it had not done before. The Bureau had written specifications for this class of vessel. The specifications had listed operational parameters, rated tolerances, performance envelopes, maximum output thresholds. The specifications had been thorough and carefully derived and had represented the best understanding of a well-funded organization that had spent 3 centuries documenting what ships could and could not do. Every specification they had written for the Icarus-class was now operating in a regime the specifications had not anticipated, against a physical environment the specifications had not measured, at a velocity the specifications had not listed, because the specifications had assumed, correctly and entirely reasonably, that a ship would never need to be rated for it. The gauges continued to register. The hull continued to distribute. The canisters continued to hiss. The Icarus flew on into territory that had no name because nothing had survived arriving there to give it one. Chapter 11. Near-Criticality. The engine room had been a different space in zero gravity. Now it was a different space again. Gravity was the wrong word for what pressed everything downward. There was no gravity, there was only the thrust vector, the continuous acceleration of the full burn translating through the ship's mass into a force that behaved like gravity in every practical sense, and was not gravity in any technical sense. Under that force, the engine room had weight. Every component in it had weight. The engineers working inside it had weight. More weight than they had carried at any point in their biological histories. Their bodies heavier against the deck plating in a ratio that corresponded to the G-load the crash couch telemetry was recording, and that their musculature was compensating for with the constant background effort of keeping themselves upright and mobile against a pull that had no interest in either. The Cherenkov radiation had been visible since the sublight transition. Before the transition, it had been present, a faint ethereal blue at the edges of the reactor housing's inspection ports, the characteristic emission of charged particles moving faster than light travels through the reactor's coolant medium. The medium was now cryogenic oxygen rather than the synthetic coolant it had been designed for, and the oxygen was doing its thermal management function and doing it well enough to have kept the reactor from breaching its physical containment. But the Cherenkov emission in an oxygen-cooled environment had a different quality than the emission in a synthetic coolant environment. It was brighter, cleaner. The blue was not the muted diffuse glow of particles scattering through an opaque medium, but the sharp directed emission of particles moving through a substance that was, at cryogenic temperatures, nearly transparent to their passage. The reactor housing's inspection ports glowed. The glow was visible from the engine room entrance. It was visible from the corridor outside the engine room entrance. It was the color of a thing that was not supposed to be visible from that distance, at that intensity, through that thickness of housing material. Vance descended the ladder from the bridge section to the engine room, with one hand on the railing and the other on the secondary pressure gauge he had detached from the monitoring array and was carrying clipped to his suit. He had been on the bridge for 3 hours of burn time. 3 hours of the acoustic register the hull was producing, 3 hours of watching the structural integrity field's flicker interval, 3 hours of Reyes calling out velocity increments with the flat precision of a system that did not require rest or reassurance or any input other than the next gauge reading. He needed to see the reactor directly. The monitoring feeds told him what the monitoring feeds could measure. The inspection ports told him something the feeds could not. The heat hit him on the fourth rung from the bottom. Not the ambient heat of the bridge, the work lamps and the processing stacks, and the drive core's thermal bloom rising through the deck plating had raised the bridge temperature to the upper edge of comfortable across the burn period, a warmth that registered as climate rather than hazard. This was different. This was the specific directional heat of a thermal source in proximity, a heat with a quality and a location, coming from the forward bulkhead of the engine room where the reactor housing occupied the full wall from deck to overhead. The housing was hot, not glowing, not yet at the visible thermal emission spectrum, but hot in the way that surfaces are hot when they have been receiving a sustained heat load for an extended period, and the thermal mass of the material has saturated to a temperature that it is going to maintain regardless of what the surface environment does. He stepped off the ladder onto the engine room deck. The smell reached him before the temperature did. Not the bridge smell. Rebreather output, processed and slightly chemical, the clean air of a sealed system. This was the smell of sustained high-temperature operation. The vaporized residue of the synthetic coolant from before the reroute, the ozone-adjacent quality of plasma in proximity to permeable housing material, and underneath all of it the particular quality of air that has had its oxygen drawn away faster than it has been replaced, a thinner register, a leaner register. The air of a space the oxygen lines were no longer servicing. His rebreather canister handled it. He noted the smell as information about the room's state and kept moving toward the lever array. The engineers were already there. 4 of them, the rotation that had come down an hour ago to relieve the previous watch. They were in their suits, not EVA sealed but thermally rated, the insulation layers providing approximately 40 minutes of workable exposure before core temperature became an operational concern. They were at the analog lever array, a bank of 8 manual control levers mounted on the port bulkhead, each lever connected by a direct mechanical linkage to a specific plasma management valve in the reactor's output architecture. The levers were the only interface left between human intention and the reactor's plasma behavior. The digital control systems had been part of the governor architecture that the purge had removed. What remained was mechanical: a lever, a linkage, a valve. The plasma was expanding. That was the condition the levers were managing. Not a breach, not a catastrophic failure, but the natural expansion behavior of plasma that had been produced by a reactor running at a sustained output level it had never been designed to run at. In a thermal environment that was managing the heat load, but not the pressure load, because heat and pressure were linked in plasma behavior, but not identical, and the oxygen cooling had addressed the heat component of the linkage and left the pressure component to be managed by the engineers with the levers. Cord was at lever 3. She had both hands on it, positioned at the mid-range of the lever's arc, maintaining a constant pressure against the resistance of the linkage that told her, through the physical feedback of the mechanical connection, what the plasma valve on the other side of the bulkhead was doing. The feedback was not precise in the way that a digital readout was precise. It was precise in the way that a craftsperson's hands are precise, interpretive, informed by accumulated experience with the specific characteristics of this linkage and this valve under these conditions, able to distinguish between normal resistance variation and a change that meant something. "Pressure is walking up on 3, she said. Not urgent. Informational. The way everything in the engine room was informational. Delivered in the same register as a gauge reading or a temperature notation. Holding with manual, but it wants to move." Vance looked at his portable gauge. The secondary pressure reading was consistent with what Cord was reporting through the lever feedback. He looked at the reactor housing, at the inspection port that was closest to Valve 3's position in the output architecture. The blue glow through the port had a slightly different quality than the ports on either side of it. The same intensity, a marginally different distribution. The emission pattern of plasma that was pressing against the valve boundary with more force than the plasma on either side of it. The difference was visible. That was what the Cherenkov emission did when the plasma pressure distribution was uneven. It showed you if you were looking at the right port at the right moment, where the boundary was being tested and in which direction it was moving. He was looking at the right port. The boundary was being tested at valve 3. "Bleed 3 into 4, he said. Cord shifted her weight and moved lever 3 forward in a controlled movement, while simultaneously signaling to the engineer at lever 4 to open his valve by a corresponding increment. The plasma flow redistributed, pressure equalizing across the boundary between the 2 valve positions, the specific port's emission pattern normalizing back to match the surrounding ports. The maneuver took approximately 30 seconds. At no point during those 30 seconds did any of the 4 engineers in the engine room stop watching their levers. The heat in the room continued to build. It was not dramatic. It was cumulative, the kind of temperature increase that a thermometer would record as a steady line rather than a spike. The thermal mass of the reactor housing saturating further into the engine room atmosphere at a rate that the rate itself obscured. An hour ago, the engine room had been warmer than the bridge. Now it was warmer than that. The difference between the 2 temperatures was not large enough to be surprising at any individual moment, and was large enough measured across the hour to matter. The primary coolant lines completed their vaporization 11 minutes into Vance's engine room watch. The process had been underway since before the sublight transition. The cryogenic oxygen cooling was managing the reactor's thermal output at its current level. But the oxygen's thermal capacity was not infinite, and the oxygen that had been circulating through the exchange system had been absorbing heat for the duration of the burn. Cryogenic oxygen at working pressure in a thermal exchange system eventually reaches the point where it has absorbed as much heat as its thermodynamic state allows, and at that point it transitions. The transition was not a rupture and was not a surprise. Morel had calculated its timing during the reroute work, had built the relief valves for exactly this event, had been watching for it since the burn began. The primary coolant lines vaporized their liquid oxygen content into gas in a sequence that moved from the hottest section of the loop to the coolest, a progressive transition that took approximately 4 minutes to complete. Each section of tubing released its pressure through the relief valves as the liquid transitioned, producing a series of soft reports in the engine room, not the sharp crack of structural failure, but the controlled release of a system doing what it had been designed to do when this specific condition occurred, each report announcing the completion of another section of the vaporization sequence. The reports moved through the engine room in the order of the loop's thermal gradient, forward to aft. A slow progression of small sounds that marked the passing of the only engineered thermal management system the ship had left. Morel was watching the relief valves. He noted each report, marked the position on the schematic, and updated the coolant loop status without looking away from the valve bank. He had designed the relief architecture. He knew what each report meant. He did not need to look at the schematic to update it. He updated it in his head. The physical document, a secondary record, the primary record, the running model he had been maintaining since the reroute went active. The primary coolant lines were no longer carrying liquid oxygen. What they were now carrying was the thermal bloom, the expanding envelope of superheated gas produced by the reactor's output, no longer being actively managed by the coolant loop's thermal exchange function, now moving through the ship's remaining thermal infrastructure by the physics of pressure differentials, rather than by any system designed to direct it. The heat had to go somewhere. The coolant loop had been where it went. The coolant loop was no longer where it could go. Vance looked at the inspection ports. The blue glow was brighter than it had been when he descended the ladder. Not marginally, noticeably the kind of increase that did not require measurement to register, that presented itself to the visual system as a change without requiring comparison to a baseline. The reactor was still contained. The plasma was still manageable with the levers. The Cherenkov emission was the visual evidence of a core that had crossed from high-output operation into a state that had a different name. It was not near criticality in the Bureau's sense. The Bureau's criticality threshold was a specific parameter, defined by a specific measurement, requiring a specific automatic response that the ship's systems were no longer capable of producing because the systems capable of producing it had been removed or disabled across the modification sequence. The monitoring feeds that would have flagged it were gone. The safety interlocks that would have triggered on the reading were gone. The logic boards that would have evaluated the pattern against the threshold table and identified the classification were on the floor of the mainframe core 3 decks above the reactor housing, trailing their severed leads. In the Bureau's framework, near criticality was a state the ship would recognize and respond to automatically. In the framework that currently existed aboard the Icarus, near criticality was a state that Vance recognized by looking at an inspection port and noting that the blue was brighter than it had been, and that Cord recognized through the resistance of a lever, and that Morel recognized through the timing of relief valve reports, human recognition, human response, analog levers. That was the framework. It was near criticality in the physical sense. The reactor was producing energy at a rate that exceeded its designed dissipation capacity, was doing so continuously, and would continue to do so for as long as the burn continued, which was for as long as the burn needed to continue. The primary coolant lines had vaporized. The crew was now relying on the only thermal management strategy left available to them: forward velocity. The Icarus was moving faster than the thermal bloom it was producing. was, in the precise technical language of their situation, outrunning its own heat. The thermal bloom expanded behind the ship at the speed permitted by the physics of superheated gas and vacuum. The ship was moving faster than that. The distance between the ship and its own thermal bloom was increasing with each second of burn, which meant the bloom was not catching up, which meant the reactor's heat was not catching up, which meant the strategy was working. The strategy was elegant in the specific way that solutions are elegant when they use the problem's own properties as their mechanism. The reactor produced heat, the heat drove the velocity outran the heat. The problem and the solution were the same object, looked at from two different directions. Vance had built the burn profile around this relationship, had derived the required velocity threshold from the thermal bloom's expansion rate and the reactor's output projection, had verified that the direct-weld injector configuration could produce the required velocity before the thermal management system reached its limit. The verification had been correct. They were past the threshold. The strategy was working. The strategy required the ship to keep moving faster than its own heat indefinitely. Cord looked at lever 3. She looked at Vance. She looked at the inspection port with its noticeably brighter blue. "Still holding," she said. "Good," he said. The engine room was approximately 18 degrees warmer than it had been when he descended the ladder. He picked up lever 7 and took his position at the array. Chapter 12. Liquefying the plating. The ablative armor had been designed to sacrifice itself. That was the architecture of it, not to deflect or absorb indefinitely, but to ablate, to lose material from its outer surface in a controlled and progressive way that carried thermal energy away from the hull in the form of the material itself. The armor did not protect the hull by being indestructible. It protected the hull by being destructible in a specific and useful way, by converting the threat into its own mass, by spending itself so that the structure beneath it did not have to. The Bureau had specified it for deep space vessels because deep space operations produced thermal loads that no fixed barrier could withstand over extended exposure, particle flux, micrometeorite impact heating, the accumulated thermal input of sustained high-output drive operation. The armor was not a shield, it was a budget. You spent it against the loads as they arrived, and when the budget was exhausted, the underlying structure was exposed, and the design assumed you would be somewhere safe before that happened. The design had not assumed this. The external telemetry feeds, the sensors mounted on the hull's outer surface to monitor the armor's condition and the environmental loads it was managing, had been producing readings since the sublight transition that the AI was logging without flagging, because the AI's threshold table had been reset, and the values the external sensors were reporting did not cross any threshold the table currently contained. The readings were not normal by any prior operational standard. They were the readings of an armor surface experiencing a thermal load that the material's specifications had not listed an upper bound for, because the specifications had been written for environments in which such a load was not achievable. The Bureau's engineers had been thorough. They had specified the armor's performance envelope across every operational condition they could model. The condition they had not modeled was relativistic travel, because relativistic travel had been in the same category as the upper bound of the armor's thermal tolerance rating. Theoretical, therefore irrelevant to operational specifications, therefore unwritten. Relativistic friction was not a term in standard Bureau documentation. It described a real phenomenon, the interaction between the hull's forward surfaces and the interstellar medium at velocities where the medium's particle density, low as it was in absolute terms, produced a cumulative heating effect through the sheer rate of interaction per unit time. At sublight speeds, the effect was negligible. Past the sublight threshold, it was not negligible. At the velocity the Icarus was currently maintaining, the forward armor surfaces were receiving an energy input that had no certified operational analog, no precedent in the Bureau's incident database. No thermal load rating to be exceeded because the rating had never been written. The armor began to go at the forward leading edge, which was where the relativistic friction was concentrated, the point of the hull that met the interstellar medium first, the geometrically exposed position that received the full particle flux before any surface behind it did. The transition from solid to liquid was not instantaneous and was not gradual in the sense of being slow. It was progressive at a rate that the thermal input determined, which was a rate that produced visible change in seconds rather than minutes. The material heated through its solid phase into a viscous state and then passed viscosity into the fluid behavior of a metal in its liquid phase, cherry red at the transition edge, deepening toward white at the hottest points. The color spectrum of thermal emission tracking the temperature gradient across the armor's face. The surface tension of the molten material was insufficient to hold it against the forces of relativistic travel. The liquid armor carried backward along the hull's exterior by the particle flux and the pressure of travel at this velocity until it reached the hull's trailing geometry and separated into the void behind the ship. The first separation was visible on the external telemetry as a mass loss event, a discrete reduction in the sensor's reading at the leading edge position, corresponding to the mass of the material that had left the hull. The AI logged it. The AI did not flag it. Vance was back on the bridge when the first separation registered. He had returned from the engine room with the engine room's heat still in the fibers of his suit, his portable pressure gauge reading the shift in secondary pressure that the bleed maneuver had stabilized, his body carrying the specific quality of fatigue that sustained work in an elevated thermal environment produced. Not the fatigue of physical exertion, but the fatigue of maintained attention under conditions that were continuously trying to pull the attention away from the task and toward the accumulating evidence of what was happening around it. He looked at the external telemetry feed on the AI monitoring display, the feed that showed the armor's status across the hull's full surface area, updated every 30 seconds from the sensor network, and watched the leading edge reading drop. He noted the value. He noted the rate of change implied by the difference between the current reading and the previous reading 30 seconds ago. He ran the arithmetic. External armor status, Reyes said from the pilot console. Not a question. She had been watching the same feed. Forward section is going. Leading edge first, moving aft at the rate the friction concentration predicts. He looked at the display. The armor is doing what it was designed to do. The design didn't account for this duration. Rate to full exposure of the forward hull section. He ran the number. At current velocity and friction coefficient, the leading edge section loses full armor coverage in approximately 40 minutes. Adjacent sections follow in sequence. She did not respond to that. The number was what it was. The adjacent sections following in sequence meant the armor reduction was going to progress from the leading edge backward across the hull over a timeline that corresponded to the distance remaining to the expansion boundary, and the correspondence was either going to be sufficient or it was not, and that calculation was already in her operational model. Outside the primary viewport, the light field produced by the velocity continued its uniform, overwhelming brightness. The blinding compression of starlight into a single, undifferentiated luminous field that carried no navigational information and no positional reference, only the visual evidence of velocity. It was the same field it had been since the sublight transition, unchanged in its intensity, unchanged in its uniformity, presenting the same featureless, luminous surface it had presented for the full duration of the burn. It was not a sky anymore. It was a wall of light, and the wall told you nothing about where you were, or how far you had come, or how far remained. It told you only that you were moving, and at this velocity, the information that you were moving was simultaneously the most important and the least actionable information available to anyone on the bridge. Against that brightness, the telemetry was telling Vance what he could not see directly, that the hull's forward surface was lit from outside in a different way, that the leading edge was not reflecting the interstellar medium's energy, but absorbing it, converting it into heat, converting the heat into the liquid phase of the armor material, losing the armor material to the void, in a slow and continuous and entirely designed process that was proceeding faster than the design had anticipated. The armor trailed behind the ship. The external telemetry confirmed it, a dispersal pattern extending aft from the leading edge, the molten material separating from the hull surface and entering the ship's wake in a continuous stream that the sensors were recording as a mass distribution extending several kilometers behind the vessel. At the temperatures involved, the molten armor did not cool quickly in the void. It remained liquid for a significant portion of its transit through the wake, a tail of bright liquefied metal trailing behind the Icarus in the darkness, visible from any vantage point with the appropriate sensor range as a comet's structural signature, the signature of a mass losing material to its environment at a sustained rate, spending itself forward into the dark. The Icarus was becoming its own comet. It was producing its own tail out of the material it had been built with, leaving a record of its passage in the void as a stream of molten metal that would cool eventually into a dispersed field of solidified droplets, marking the trajectory of something that had come this way at a speed that had no precedent. Nothing that had come this way at this speed had left a trail before, because nothing had come this way at this speed before. The heat began crossing the hull into the interior 40 minutes into the bridge watch. Not the reactor's heat. That was rising through the deck plating as it had been since the burn began, a vertical thermal gradient produced by the engine room's condition and distributed upward through the ship's structure. This was lateral heat, coming through the forward bulkhead from the exterior, from the surface that was now losing its armor coverage and receiving the full relativistic friction load on the underlying hull plating without the armor's ablative budget between them. The hull plating was not the armor. The hull plating was the structure, the titanium skin of the vessel, the primary barrier between the interior atmosphere and the void, not designed for ablation, not designed to sacrifice itself, designed to maintain its geometry and its integrity under the operational loads the Bureau had specified. The loads the Bureau had specified did not include this, and the hull plating was not equipped with the philosophical flexibility to distinguish between a load it had been specified for and one it had not. It responded to what it received. The forward section of the bridge deck plates registered the thermal input first. The registration was physical, a change in the material's behavior under the ongoing stress of the burn, the deck plating's thermal expansion adding to the mechanical stress already present from the G-load and the structural integrity field's management load. The combined stress producing a slow, visible deformation in the forward section of the bridge floor. Not buckling in the catastrophic sense. Deforming, the plates moving from flat to slightly convex as the thermal expansion differential between the heated forward face and the cooler interior face created a bending moment in the material that the material resolved by changing its geometry rather than by changing its state. Reyes felt it through the crash couch's contact with the deck. The couch was bolted to the deck, and the deck had moved, and the movement had transmitted through the bolt into the couch's base frame, and from there into the body of anyone in the couch. She registered the movement, identified its source from the direction and character of the transmission, and looked at the thermal monitoring feed. The forward deck plates were running 40 degrees above the aft deck plates. Whole thermal gradient, she said. The same notation register. The number delivered. Leading edge is bare, Vance said. He was looking at the external telemetry. The sensor at the leading edge position had dropped to 0. Not a sensor failure, a coverage loss. The armor at that position fully consumed. The sensor now reading the thermal environment of exposed hull plating in direct contact with the relativistic particle flux. The reading was not a temperature the hull plating specifications had been written for. He looked at the deck plates. The forward section's deformation was visible from where he stood. A subtle convexity, a geometry that had not been there when the burn began. a change in the shape of the floor that the floor had not been designed to make and could not make back. Thermal deformation in titanium at this magnitude was permanent. The crystal structure of the metal had reorganized under the stress, the atoms finding a new equilibrium position that was lower energy under the combined thermal and mechanical load, and that was not the position they had occupied when the plate was manufactured. The deck plate had a new shape now, and the new shape was what it had instead of its original shape, and the two shapes were not recoverable from each other. And the same process was happening in every forward-facing structural surface on the ship simultaneously. A systematic and irreversible rewriting of the Icarus's geometry from the outside in. Cord looked at the same section of deck from her position at the secondary monitoring console. She looked at it the way she had looked at the primary rib junction on the first walkthrough, with the attention of someone reading a structure's communication rather than inspecting it for compliance. On the first walkthrough, the rib junction had told her the hull was specific rather than obsolete. What the deck plate was communicating now was specific and clear in a different way. Not the character of a structure doing its job, but the record of a structure being changed by a job it had not been designed to do. The convexity was not damage in the catastrophic sense. It was evidence. It was the floor telling you what the burn was doing to it in the only language a floor had, which was shape. "The hull isn't burning," she said. She was still looking at the deck, at the convex section, the deformed geometry, the shape that had replaced the shape the ship had been built with, at the record of something becoming something else, one crystal structure at a time. It's forgetting its original shape. The ablative armor continued its work in the void behind them. The leading edge continued its exposure to the unmediated particle flux. The forward deck plates continued their slow deformation under the thermal gradient, their crystal structures reorganizing incrementally toward a new equilibrium that was not the equilibrium they had been built for. The Icarus flew on, shedding its external geometry into its own wake in a continuous bright stream, becoming incrementally less like the vessel that had entered Sector 4, and incrementally more like the thing it was becoming. Not a ship in any specification sense, not a vessel in any bureau category, but a directed event, a moving point of energy and titanium and human intention that was consuming its own structure as fuel for its forward progress, becoming lighter and hotter and faster and less like itself with every kilometer it covered, which was precisely what the burn required, which was the only thing any of it had ever been designed to produce. Chapter 13. The Momentum Trap. The G-load had always been there. From the moment Reyes broke the detent, it had been present. A weight that was not weight, a force without a source in the traditional sense, the product of continuous acceleration applied to mass for long enough that the distinction between acceleration and gravity became academic. The crash couches had been managing it. The restraint systems had been managing it. The crew's bodies had been compensating for it with the constant background expenditure of muscular effort that kept them oriented and mobile and capable of performing the functions the burn required. They had been living inside the G-load for the full duration of the burn, adapting to it in the incremental way that human physiology adapts to sustained environmental stressors, not eliminating the stress, but building tolerance to its baseline expression, the way any organism adjusts to a condition that is present and continuous and must be worked around rather than resolved. The G-load changed, not suddenly, not in the discrete, event-like way that the clamp failures had changed the ship's acoustic signature, or the way the sublight transition had changed the visual field outside the viewport. It changed the way temperature changes in a room that has been warming for a long time, gradually, at a rate that at any individual moment was insufficient to register as a threshold crossing, producing its cumulative effect through the persistence of small increments rather than through any single increment that could be identified as the moment of change. The burn's forward acceleration was not varying. The drive output was at maximum and had been at maximum, but the velocity was increasing. and at relativistic velocities the relationship between acceleration and effective g-force was not linear. What the crew experienced as g-load was the product of multiple contributing factors, and one of those factors was velocity, and velocity was rising. At the velocity the Icarus was currently sustaining, the relativistic mass curve had begun to assert its influence on the force calculations in ways that were not negligible. The ship's effective mass was increasing as its velocity increased. The universe's tax on moving fast, the cost of approaching the limit that defined the behavior of everything with mass in the cosmos. The drive was compensating. The drive was producing more output than it had been producing at the burn's start, not because Reyes had advanced the lever was at maximum and had been at maximum, but because maximum output against an increasing effective mass produced a different result at each velocity than it had at the previous one. The ship was working harder to sustain its velocity than it had been. The G-load was the evidence of that work, multiplied through every kilogram of mass aboard. Reyes noticed it in her hands. She had been maintaining her grip on the primary thrust lever since the detent broke. The grip was habitual at this point, not a conscious decision renewed at intervals, but a physical state she had settled into. The muscles of her hands and forearms in the specific configuration that kept the lever where it was, without requiring active management of the effort. The lever did not require pulling or pushing. It was locked at maximum, the detent bypassed, the drive output committed. But her hands were on it because her hands had been on it, and because there was a quality of rightness to having her hands on the lever that the cognitive functions running under the G-load were not currently able to interrogate. Her hands were on the lever. That was correct. The grip became harder, not because the lever moved, not because any change in the drive interface required additional force. The lever was stationary. What had changed was the weight of her arms. The G-load's incremental increase had added a fraction to the effective weight of every kilogram of mass on the ship, including the kilograms of her forearms and hands positioned above the lever. Holding her arms in the position they occupied now cost more than it had cost 30 minutes ago. The cost was small per increment and was accumulated over the full burn duration, and the accumulated cost was now registering as a sustained muscular effort that was not large in absolute terms and was ongoing without interruption and was the kind of thing that compounds. She did not move her hands. In the secondary monitoring station that Cord had occupied through the earlier hours of the burn, the station itself was making a sound. Not the processing stack hum of the AI's monitoring functions, not the ventilation fans, not the rebreather canisters. A new sound. A sound that did not belong to any system that had been producing sound in the bridge. It was the sound of the station's mounting hardware under load. The bolts in the deck brackets that held the station's base frame to the floor. Each bolt a point of connection between the station's mass and the deck structure beneath it. Each bolt now carrying a fraction of the station's effective weight that had been multiplied by the same factor that was multiplying every other mass relationship on the ship. The bolts were not failing. They were straining, and the strain had a sound, and the sound was audible in the bridge's current acoustic environment because the bridge's current acoustic environment had thinned. The crew's activity level was lower, their movement reduced, the noise generated by human presence in the space proportionally diminished as the G-load's increasing cost made movement more expensive and therefore less frequent. Vance heard it from his position at the engineering console. He heard it and cataloged it without turning his head to look at the station, because turning his head required elevating it against the G-load, and the return value of the visual information did not at this moment exceed the cost of the effort. He could hear what was happening. The sound told him what he needed to know. The server racks went first. The server racks lived in the secondary corridor that connected the bridge to the mainframe core, a bank of 9 equipment racks, each housing processing and storage hardware that had supported the ship's operational systems in its service period. Each rack mounted to the corridor bulkhead with the standard industrial mounting hardware rated for the vibration loads of normal operational burn. The racks weighed, in standard gravity, approximately 200 kilograms each. In the current effective gravity environment produced by the burn's G-load multiplier, they weighed considerably more. The mounting hardware's rated load had been established for normal operational conditions. Normal operational conditions had been over since the detent broke. The first rack's upper mounting bracket sheared. The sound reached the bridge as a single sharp crack, audible over the other sounds of the corridor in the specific register of a metal component, releasing from tension at its failure point. The rack pivoted on its lower mounting, the upper bracket no longer constraining its top section, the rack's mass redistributing toward the floor in the direction the effective gravity was pulling it. The lower mounting held for 3 seconds, the remaining bracket taking the full weight of the rack in a configuration it had not been designed to manage, and then the lower bracket failed as well. A second crack, less sharp than the first, the sound of a component failing under sustained overload rather than sudden release, and the rack completed its transit to the corridor floor in a controlled collapse, its housing structure deforming on impact, the equipment inside making the sound of hardware that was no longer in a rack. The second rack followed 12 seconds later, then the third. The corridor between the bridge and the mainframe core was filling with fallen hardware. Each rack as it went added to the acoustic record of the event, a sequence of failures, each one distinct, each one adding its mass to the debris accumulation on the corridor floor that was itself now subject to the same G-load that had brought the racks down, pressing the fallen hardware against the floor plating with a force that the floor plating was managing and that the fallen hardware was not. The casings deforming slowly under their own multiplied weight in a process too gradual to be dramatic and too steady to stop. The crew did not leave their positions to investigate. Leaving a position was not, at this G-load level, a simple action. It was a calculation. The crash couch restraint systems were managing the load efficiently, the couplers distributing the force across the body's contact surface with the couch. The design's intent being exactly this situation, the restraint system's rated capacity providing the margin that the crew's own musculature could not provide unassisted. Standing from the couch required disengaging the restraint system, which required operating the release with hands that were heavy, which required elevating the body from a supported position to an unsupported one, in a gravity equivalent that was well above the training threshold for unassisted standing. It required expenditure of physical resources that were finite and were not being replenished at a rate that allowed casual expenditure. They stayed in the couches. The sounds from the corridor continued. The internal bulkheads had been moving since before the server racks went down. Not visibly in the sense of fast, dramatic movement, but in the same slow, cumulative way the deck plates had been deforming under the thermal gradient. The bulkheads were structural panels, load-bearing elements of the ship's secondary frame, their mounting hardware and their material properties specified for the loads that the Bureau's design parameters had encompassed. The G-load multiplier was not among those parameters. Under a force that increased the effective weight of every kilogram in the ship by the burn's current multiplier, the bulkhead's own mass became a load they were required to support against the geometry of their mounting position. And the mounting position, vertical, oriented perpendicular to the direction of the effective gravity, was not the loading geometry the hardware had been designed for. The port secondary bulkhead of the bridge section began its descent over a period of approximately 8 minutes. It was not a collapse in the event sense. It was a progressive yielding, the upper mounting hardware deforming first, the panel tilting away from vertical by increments small enough that each increment was negligible, and the cumulative effect was a panel that was no longer perpendicular to the deck. As the tilt increased, the load on the remaining mounting hardware increased in proportion to the trigonometry of the mounting angle, which meant the deformation was self-accelerating. Each degree of tilt increased the load on the mounts, which increased the rate of tilt, which increased the load. The acceleration was gentle. At the end of the 8 minutes, the port's secondary bulkhead was at approximately 40 degrees from vertical and had found a new equilibrium in contact with the secondary processing rack that had been mounted to the opposite wall, the rack providing an unplanned but structurally adequate support surface for the tilted panel. The secondary processing rack contained the last active elements of the bridge's internal monitoring system: the feeds from the structural integrity field sensors, the thermal monitoring array, the remaining pressure gauges that were not part of Vance's manually relocated set. The rack's upper section, now in contact with the descended bulkhead, was receiving a compressive load from the panel's mass that the rack's housing was managing with the specific dignity of hardware that has been asked to function as a structural element without having been designed as one. It managed for 4 minutes and 11 seconds. Then the rack's housing failed at the upper section, the contact load exceeding the material's compressive rating, the housing collapsing inward and carrying the hardware inside with it. The feeds the rack was supporting went dark in sequence as their hardware lost power. Structural integrity first, then thermal, then pressure, each feed disappearing from the AI's monitoring display as the physical equipment producing it ceased to produce it. The AI's monitoring display showed green across the remaining active feeds. The remaining active feeds were 3. In 30 seconds, they were 2. In a further 40 seconds, they were 1. Reyes watched the display narrow. She watched it without being able to turn her head significantly. The G-load made the rotation expensive, and the display was not far enough from her direct sight line to require a full turn. She watched the last feed holding its reading on the display, a single data stream from a single sensor in a location that had not yet been subject to the cascade of mounting failures working its way through the ship's secondary structure. The sensor was in the aft engineering section. It was reading the engine room's ambient temperature. The reading was high. It had been high since Vance's first watch on the engine room deck, and it had risen steadily since, and it was now at a level that the original threshold table, before the purge, before the admin override, before the concept of structural integrity was removed from the directory, would have flagged as a critical emergency event requiring immediate automated response. The AI observed the reading. The AI found nothing to flag. The AI was performing correctly. The temperature reading held for another 20 seconds, and then the sensor housing failed under its own mounting hardware load, and the last feed disappeared from the display. The monitoring display showed green across no active feeds. The bridge had no information from any internal system of the ship except what the manually relocated gauges in Vance's direct sightline were reporting, and what Reyes's primary thrust indicator was reading, and what the rebreather canister's capacity displays were showing, and what the crew's own bodies were telling them about the environment they were in. The Icarus was flying entirely without instruments now. What it had instead was velocity, which was the only instrument that had ever mattered, and which was still increasing. The crew was still in the couches. Their hands were still where they needed to be. Their rebreather canisters were still cycling. The monitoring display was showing green across no active feeds, which meant the AI was observing nothing and flagging nothing and performing its function correctly within parameters it had been given. And the parameters it had been given were the parameters Vance had left in the threshold table, which was no parameters at all. Green was what you got when nothing was left to measure. Green was the bridge's current state, and the crew was in it, and the velocity was still rising, and momentum was now the only operational state available to any of them. The crew, the ship, and the thing they were flying toward, which was somewhere ahead in the blinding, featureless light that had been the entire visible universe for the full duration of the burn. Chapter 14. Detachment. The cascade had been running for a long time before anyone stopped trying to stop it. That was the precise nature of the transition. Not a decision, not a moment where one of the 9 crew members in the bridge or the corridor section consciously evaluated the cascade's current state and concluded that further intervention was not warranted. It was a gradient. The interventions had become smaller and less frequent over the hours of the burn, not because the failures were slowing, but because the cost of intervention was rising faster than the value of any individual intervention was rising. And at some point, across that gradient, the equation had resolved in a direction that was not intervention. The crash couches were managing the G-load. The rebreather canisters were managing the atmosphere. The velocity was managing the thermal bloom. The analog levers in the engine room were managing the plasma expansion with the 4-person watch that had been cycling down there since the coolant lines vaporized. Those 4 systems were managing the 4 things that required management. Everything else was failing, and the failures were cascading, and the cascade was producing sounds and sights and physical sensations that were available to the crew's sensory systems, and the crew's sensory systems were processing them, and the processing was not producing the response that it would have produced at the beginning of the burn. At the beginning of the burn, there had been a category of inputs that warranted response and a category that did not. The category that did not was small and well-defined: background systems, ambient indicators, the ongoing sounds of normal operation. The category that warranted response was everything else, which was most things. Across the burn's duration, that ratio had inverted. The category that warranted response had been addressed, progressively, by the modification sequence and the burn's own logic. Each thing that could be done had been done. Each adjustment that mattered had been made. What remained in the warranting response category was a set of ongoing conditions that had no available response. The velocities continued rise, the cascades continued expression, the armor's continued ablation, the hull's continued deformation. Ongoing conditions with no available response were, in the operational model Vance had been running his entire career, equivalent to conditions that did not warrant response. The model had updated. The ratio had inverted. At the beginning of the burn, a sound from the secondary corridor would have produced a physical response, an orientation of attention, a motor impulse toward investigation, the specific alertness of a trained operator responding to an anomalous input. The response had been appropriate then. The response had been the correct output of a nervous system in an environment where anomalous inputs warranted investigation, because investigation could produce useful intervention. The environment had changed. The port secondary bulkhead had descended. The server racks were on the floor. The secondary monitoring feeds were dark. The corridor between the bridge and the mainframe core was a landscape of fallen hardware and deformed structural panels, the accumulated debris of a ship's internal architecture collapsing under a G-load that was still rising, producing new sounds at intervals as the next mounting bracket reached its failure point and the next component began its transit to the floor. The sounds were regular in the way that dripping water is regular, not metronomic, not precisely timed, but belonging to a frequency and a character that the auditory system could categorize and set aside rather than process as novel stimulus. The sounds were the cascade expressing itself. The cascade was going to continue expressing itself regardless of whether anyone processed it as novel stimulus. Orienting toward the sounds produced no useful output. The nervous system, provided with this information across sufficient repetitions, updated its response template. It became easier to watch than to move. Vance noticed this in himself first, which was appropriate. He was the person on the bridge most accustomed to auditing his own cognitive state in operational conditions, the habit of an engineer who had spent a career distinguishing between what he was observing and what he was inferring from what he was observing. He noticed that he had been watching the starboard secondary bulkhead slow tilt for some time without having developed any plan for what to do about it. The tilt was advancing at its self-accelerating rate, each degree increasing the load on the remaining mounting hardware, the hardware yielding in proportion. He had been watching it. He was aware that the watching was not intervention. He was aware that he had the capacity to attempt intervention. The crash couch restraint system was engaged but not locked. He could disengage it, he could stand. He could apply the resources he still had to the bulkhead's mounting hardware with whatever tools were within reach from a standing position in the current G-load environment. He had not done this. He had watched the tilt advance. The watching had a quality that the monitoring behavior of the earlier burn hours had not had. Earlier, monitoring had been purposeful, a directed allocation of attention toward information that fed a model that produced decisions that produced actions. The watching now was different. The information was still arriving. The model was still running. The decisions were still theoretically available. The chain of purposefulness had not snapped at any single point. It had simply become longer, and the length of it had changed the quality of the process at the input end, which was the sensory information, which was arriving with an intensity that the earlier burn hours had not produced because the earlier burn hours had been about preparing for something rather than experiencing something. The something was now. The starboard secondary bulkhead found its contact point with the processing equipment on the opposite wall and came to rest at approximately 38 degrees from vertical. The contact produced a sound, not the sharp crack of a sudden failure, but the sustained low groan of two structural elements finding their equilibrium against each other, the sound of mass at rest in a new configuration. The groan extended for several seconds and then resolved into silence, and the silence had a quality that was different from the silence before the groan. A silence that contained the new geometry rather than the anticipated event. Outside the primary viewport, the blinding light field continued its absolute uniformity. There was nothing to see in it that changed or developed or produced new information. It was the same thing it had been for the full duration of the burn, the same overwhelming, featureless brightness, and what it was showing the crew was the same thing it had always been showing. Speed. Impossible speed. The universe's visual acknowledgement that something was moving through it at a rate that the universe had not anticipated needing to accommodate. The light was the evidence. The light was not changing because the speed was not changing in the directional sense. It was still forward, still maximum, still the only vector available to a ship that had no braking capacity and no reason to brake even if it had. Something about the light's constancy had become, across the burn hours, not oppressive but immersive. This was the word Vance reached for when he became aware that he had been looking at the viewport for an untracked interval without being aware of looking at the viewport. Immersive. The light had not changed. His relationship to the light had changed. The light was no longer a feature of the operational environment that he was tracking for information content. It had no information content, had had no information content since the navigational displays shattered, and his monitoring attention had long since redirected from the viewport to the gauges that contained actual data. But the light was still present in his peripheral visual field, and the peripheral visual field had been receiving it for long enough that the processing of it had migrated from the active attention systems to something that did not have a precise label in operational vocabulary, but that felt from the inside like being inside the burn rather than observing it. He was inside it. The rebreather canister hissed its soft rhythm at his face. The G-load pressed him into the couch with its steady, multiplied weight. The hull produced its distributed acoustic signature through the deck plating and the couch's contact surface and the base of his spine. The engine room's analog lever array was being managed 3 decks below by 4 engineers who were in the same operational condition he was in, doing the thing that required doing, in the environment that the burn had produced. The cascade was cascading. The speed was rising. Cord's voice came from the secondary monitoring position, where she had been for the past several hours, and was still, her rebreather canister reading at approximately 30% capacity on its display, her hands resting on the console surface rather than operating anything because the console had no active systems to operate. She was not reporting a problem. She was not flagging a reading. She said, "Look at it." Not a directive, not a command, an observation offered to the room. The specific register of sharing something that is being experienced rather than something that requires a response. The something she was indicating was not specified. It was everything. The light, the sound, the G-load, the cascade's ongoing expression through the ship's secondary architecture, the speed that the gauges confirmed and the light evidenced, and the body communicated through the press of the couch and the weight of the arms and the particular quality of the rebreather's rhythm in the current atmospheric condition. Nobody looked away from what they were looking at. Vance looked at the viewport. The light in the viewport had not changed. The light in the viewport had not changed for hours, and would not change for as long as the burn continued, and was going to continue for as long as the burn was going to continue, which was until it was done. He looked at the light, and the light looked back at him with the complete indifference of physics. The complete indifference of something that was not performing for an audience, but simply existing at the intersection of the ship's velocity and the interstellar medium's photon density. And the indifference was not hostile, and was not comforting, and was exactly what it was, which was real. The fear was still technically present in the physiological sense. The adrenal architecture was still operational, the stress response hardware was still installed and had not been removed by any modification, and the inputs that would trigger it were present in the environment in sufficient quantity that a body in standard operating condition would have been running on sustained cortisol for the full duration of the burn. The body's response systems had been running on the inputs they received and were still running on them. And what the systems had produced across the burn's duration was not the acute fear response of a threat that had arrived suddenly and could potentially be escaped. It was something that the acute fear response had converted into across sustained exposure. The way any sustained input converts, flattening, habituating, the signal still present, and the nervous system still registered, but the quality of the registration changed by the duration of the registration. The fear was a background condition. The speed was the foreground. The physiological high had arrived the way the G-load change had arrived, gradually through accumulation, without a discrete moment of onset that could be identified as the beginning of it. It was not euphoria in the chemical sense of an artificial elevation of hedonic baseline. It was the specific state produced by a nervous system that has been running at maximum stress load for an extended period and has exhausted the resources required to maintain that load at its acute expression, and has therefore reduced the acute expression to a sustainable level, and in doing so has freed the cognitive bandwidth that the acute expression had been consuming. The bandwidth was available. The environment was providing input at an intensity that the available bandwidth could process without the filtering that fear applied. The input was extraordinary in the most precise sense of that word. The processing of it, unfiltered, was a form of clarity that had no standard reference in ordinary operational experience. The speed was extraordinary. This was the word that arrived for it, unbidden, not as a thought, but as a recognition. The specific cognitive event that occurs when the gap between expectation and reality becomes large enough that the processing system produces a classification rather than a plan. Extraordinary, beyond the ordinary. The ordinary being what ships could do, what certified drives produced, what the Bureau's specifications encompassed, what any calculation built on prior experience could have predicted. All of that was behind them. What they were doing now was not in any prior calculation. They were the data that would produce new calculations for whoever came after, if anyone came after, if the black box reached anyone who could read it, if the galaxy that was currently being compelled to accommodate their velocity had enough remaining architecture to support the civilization that would build the instruments to find the box and decrypt what the box contained. A sound moved through the ship from aft to forward. It was different from the cascade sounds. Not a mounting failure, not a bulkhead finding its new equilibrium. It was the hull's primary acoustic signature at a new register, deeper than it had been in the previous hour. The sound of the primary spine distributing a stress load that had increased with the velocity's increase. the frame doing its specific thing in the new conditions the velocity had produced. The sound traveled the 87 meters of the spine in approximately a third of a second, and arrived at the bridge as a deep, sustained tone that resonated in the couch's contact surface, and in the deck plating under the couch's base, and in the chest of anyone in contact with any surface connected to the frame, which was everyone. Everyone felt it. No one moved. The speed was still rising. The hull was still distributing. The canisters were still cycling. The light was still there. The cascade was still expressing itself in the sounds of a ship becoming incrementally simpler, shedding the complexity it had begun with in proportion to the velocity it had achieved. The two quantities in a relationship that no specification had written because no specification had imagined needing to. Vance looked at the viewport and felt the tone move through him and did not reach for anything. The burn had taken everything it needed from them, and what remained after it took everything it needed was this. 9 people in a ship that was moving faster than the universe had rules for, watching it happen, which was the only thing left to do, which turned out to be enough. Chapter 15, Folding the Wake. The forward viewport showed it first. The primary viewport, the narrow reinforced strip at pilot console height, had been showing the blinding, uniform field of compressed light since the sublight transition. That field had been constant, featureless, the visual evidence of velocity without any other information content. What it was showing now was not a field. The field had been replaced by something that the visual system received as a field, but that the visual system's language for fields was not adequate to describe. It was not a color. It was not a brightness. It was a geometry, a quality of depth and structure and directional information that had not been present in the previous phase of the viewport's output, emerging the way structure emerges from any sufficiently pressured system when the pressure exceeds the threshold below which structure can be avoided. Space was folding. The word was not quite right. Words were a vocabulary built from observation of ordinary phenomena, and what was happening outside the viewport was not an ordinary phenomenon, and had not been observed before by anyone in a position to contribute to the vocabulary. Folding was what it looked like. The interstellar medium, the sparse distribution of particles and radiation that occupied the space between stars, was being organized by the Icarus's forward gravity well into a geometry that the visual system processed as a surface bending toward a point. Not the point of the ship's nose, the point of the ship's velocity, which was ahead of the physical vessel in the sense that the gravity well's distortion of space preceded the hull that was producing the distortion, a horizon effect at relativistic speeds where the physics of the situation arrived before the object creating the physics. The gravity well was not a designed feature of the Icarus-class hull. It was a consequence, the product of a mass moving at a velocity sufficient to produce a measurable curvature in the space-time fabric, the universe responding to the ship's momentum with the only response available to it, which was geometric. Space curved around mass in motion as a function of the mass and the velocity. The Icarus had always had mass. What it had now was the velocity, and the velocity was enough. The well it was dragging ahead of itself was real, was measurable, was producing effects that were visible through the viewport as the fold, and was deepening with every increment of velocity that Reyes's gauges were recording, and that the universe was incorporating into its ongoing adjustment to the presence of this particular mass, moving this fast through this particular region of space-time. The stars were bending. This was visible in the viewport's peripheral regions, the edges of the strip of reinforced glass where the forward field gave way to the side geometry, where the starlight that was not directly ahead had been reaching the viewport from angles that the velocity was now sufficiently modifying to produce a visible deflection. The deflection was not a gradual curve. It was a sharp, almost mechanical bend, light traveling in a straight line through space that was no longer flat, the line arriving at the eye as a bend. Because the space it had traveled through had been curved by the gravity well, the way a straight road appears curved when the terrain beneath it is curved. The light had not bent. The space had bent, and the light had reported the truth of it. Reyes had been watching the viewport continuously since the visual field first changed, not the directed purposeful monitoring of a pilot tracking navigational data, but the watching that the crew had been doing in the hours of the Burns detachment phase. The watching without agenda. The processing of the environment as environment rather than as information to be acted on. She had not reported the change when it began. The change was visible to anyone in the bridge who was looking at the viewport, which was everyone, because the viewport was what there was to look at. She had watched it develop through its stages, the first barely perceptible modulation of the uniform field, the first emergence of the bending geometry at the peripheral edges, the progression of the fold as the velocity pushed the gravity well's distortion radius further ahead of the hull. She watched it now and said, "Final vector coordinates, 0.97 of light, heading unchanged." Her voice was quiet, not the restricted, effortful quiet of high G-load speech, but the quality of quiet that belongs to someone whose operating environment has reduced the range of meaningful outputs to a small and specific set, and who is delivering one of them. Nobody asked her to repeat it. The fold had a texture that the word texture was not built for. It was the texture of space that had been organized by a moving mass, not the smooth, undifferentiated fabric of space at rest, not the compressed uniformity of the sublight transition's blinding field, but a structured intermediate state in which the directions that had previously been equivalent were no longer equivalent, in which the geometry of toward and away had been bent into something that the visual cortex processed as depth without having a category for the specific depth it was processing. Looking into it was like looking into a well whose bottom was in a direction that was not down. Looking away from it was, at this point in the burn, not something that anyone in the bridge was doing. The hull was making a sound it had not made before. The distributed acoustic signature of the primary spine under relativistic stress had been present since the sublight transition. The deep layered resonance of 87 meters of titanium distributing a load across every primary rib junction simultaneously. The sound that moved through the ship in the direction of the stress rather than in the direction of the sound waves, felt before it was heard in the chest before the ears processed it as acoustic information. That sound was still present. What was new was a harmonic, a frequency riding on top of the primary signature, produced by the structural integrity field's interaction with the curved space the ship was now moving through. The field was designed to maintain a specific shape relative to the hull's geometry. The hull's geometry was moving through a space that was itself no longer flat. The field's control systems were managing the interaction, had been managing the interaction since the fold began. But the management had a cost, and the cost was audible as the harmonic, a high, sustained note that occupied the upper registers of the primary resonance's frequency space, and that resonated in the skull and the teeth and the reinforced glass of the viewport itself. Through the viewport, the fold deepened. The stars at the peripheral edges were no longer visible as individual sources. They had been drawn into the bend of the geometry, their light arriving at the viewport after transit through space that was more thoroughly curved than it had been when the fold began, their individual character lost in the curve as the curve's depth exceeded the resolution of the visual system's ability to distinguish them. What replaced them was a continuous arc of light at the edge of the viewport's field, not the streaks of the sublight transition, not the compression of the earlier velocity phases, but a ring, an arc, the visual expression of all the starlight in the hemisphere behind the ship's direction of travel being bent around the gravity well and arriving at the viewport from a geometry that was not behind the ship. The viewport was showing the crew the stars that were behind them. Not because the viewport faced backward, because the space had been bent. The light from those stars had been traveling in a straight line through space that was no longer straight, and it had arrived at the viewport from a direction that was not behind them in the physical sense, but was behind them in the geometric sense of a space that had acquired a shape from the passage of the ship through it. The stars behind the Icarus were visible through the viewport that faced forward. The ship was moving fast enough to see the back of its own wake. Vance looked at the fold and said nothing. There was nothing to say that the fold was not already saying. Nothing that a sentence could add to the visual information of space organizing itself around the ship's velocity, the universe making room for something it had not previously needed to make room for. He had spent the preparation months and the burn hours in the specific register of a person who understood the physics and was therefore working within a conceptual framework that accommodated what was happening. The conceptual framework accommodated it. The experience of it was something the conceptual framework described without producing. This was the specific limitation of working from calculations rather than observations. The calculation told you what would happen, gave you the shape of the event in numerical form, allowed you to plan for it and build toward it and stake everything on it. The calculation did not give you what it would look like from inside it. The calculation did not give you the harmonic in the teeth or the arc of bent starlight at the viewport's edge, or the quality of the fold's texture that the word texture was not built for. The calculation gave you the number. The burn gave you the thing behind the number. You could know that space would fold and still not have available to you, prior to the moment of observation, what folded space looked like. It looked like this. The Icarus ceased to be a functional vessel in any specification sense approximately 37 minutes after the fold began. Not in the sense of catastrophic structural failure. The spine was still distributing. The plasma management was still being managed. The rebreather canisters were still providing the atmosphere the crew required. It ceased to be a functional vessel in the sense that the category functional vessel no longer described the physical object that was moving through the fold at this velocity and this geometry. A functional vessel was a thing designed to carry people and systems through space in a controlled and purposeful way toward a destination, with the means to navigate and decelerate and arrive. The Icarus had no navigation. It had no deceleration capacity. It had one direction and one output level and one operational state. It was not a vessel in the functional sense anymore. It was a projectile, a directed mass moving through curved space at a velocity that was still rising, carrying inside it 9 people and the analog levers and the canisters and the gauges that Vance was still watching, still reading, still updating his operational model from even as the operational model's actionable outputs approached 0. The model's last actionable output had been the engine room lever adjustment 3 hours ago. The model was still running. Reyes watched the arc of bent starlight at the viewport's edge. She watched the fold's continued development, the stars that had been at the outer edge of the arc moving further into the geometry as the fold deepened, the arc thickening as the bending radius decreased with the gravity well's increasing intensity. She watched the hull's thermal monitoring feed on the single surviving analog gauge that was positioned in her sight line. Not in the engineering array she had been reading since the burn began, but a secondary gauge mounted to the port console housing, showing the forward hull section's current temperature. The temperature was above the hull plating's rated maximum operating range. The temperature had been above the rated maximum operating range for some time. The hull was managing it in the way the hull managed everything, by distributing the stress across the full secondary frame, by not failing at any single point faster than the distribution could compensate, by being the thing it was specifically built to be. The hull was not burning, it was folding the weight behind it. The visual expression of unchecked thermal energy tearing through the dark spread aft from the Icarus's position in the fold, the molten armor still shedding from the leading edge, the thermal bloom still being outrun by the velocity, the structural integrity field's harmonics still vibrating in the teeth and the glass and the primary spine, and all of it organized by the fold into a wake that was not a straight line behind the ship, but a curve. The evidence of the ship's passage organized by the same geometry that was bending the starlight, the wake curving through the fold. The way water curls behind a fast boat through a medium that has a shape. The medium had a shape now. The Icarus had given it a shape. The physical laws of the galaxy had been accommodating something they had not previously been required to accommodate, and the accommodation had produced a geometry that was visible from the viewport as the fold, and the fold was deepening, and the deepening was the visual evidence of the thing that the burn had been built to do, which was not to destroy the Icarus. The Icarus was incidental, a delivery mechanism, a vehicle that was becoming fuel for its own velocity. But to reach the boundary, to punch through the edge of the thing that was going to kill everyone, to find out if a 0.03% probability was enough to save anyone on the other side of it. Reyes looked at the fold. She looked at the hull temperature gauge. She looked at the fold again. The physical laws of the galaxy, she said, are beginning to visually tear apart around us. Not distress, not awe in the theatrical sense. A notation, precise and flat, the delivery of an observed fact in the register she had been delivering, observed facts in since the beginning of the burn, since the bolt went into the lock cradle, since the anomaly data arrived at 0300 and she had written a single word at the bottom of her projection: irrelevant. The certified options were irrelevant. The specifications were irrelevant. The Bureau's 3 centuries of accumulated operational data were irrelevant. The fold was not irrelevant. The fold was what the 0.03% looked like from the inside, and it was the most specific, concrete, physically present thing that any of them had ever seen, and the canisters were still cycling, and the velocity was still rising, and the fold was still deepening, and the Icarus flew on into the tear it had made in the ordinary, through the space it had compelled to have a shape, toward the boundary that had made all of this necessary, and that was now, at this velocity, at this geometry, beginning to be close enough to see. Chapter 16. Total Structural Collapse. The structural integrity field had been flickering for hours. Not the 4 to 5 second interval flicker of the early burn, the manageable periodic variation that the hull's primary spine had been distributing around at each dropout. That interval had compressed as the velocity increased and the fold deepened, the field's control systems working harder against the curved space geometry to maintain the calibrated shape the hull required, the working harder expressing itself as a shorter cycle between corrections, each correction more aggressive than the last. The current interval was less than 2 seconds. The dropouts were lasting longer. The half second of unaugmented load that had been the early burn's dropout duration had extended to nearly a full second. And in that full second, the primary spine was carrying the complete relativistic load without electromagnetic supplementation. And the full relativistic load at the current velocity was not the load the field had been designed to supplement. The harmonic in the hull was not a harmonic anymore. It had been a harmonic, a secondary frequency riding on the primary resonance, audible in the teeth and the glass and the base of the skull, the specific acoustic signature of the field's interaction with curved space. Across the burn hours, it had risen in pitch and intensity as the fold deepened and the field's interaction with the geometry intensified, climbing through the registers of audible frequency in the way that a sustained note climbs when the source of it is increasing its output. Now it was a component of the primary resonance rather than a rider on it, indistinguishable from the hull's structural voice, integrated into the sound the ship was making. The 2 frequencies locked into a single acoustic event that occupied the full range of the sensory experience simultaneously. Vance heard the primary spine go. He was in the crash couch. He had been in the crash couch for the hours of the detachment phase and had not moved from it, because movement was no longer a resource he had in the quantity that movement required. The G-load's weight on his body was the weight of a man who had become heavier than himself, and the couch was managing the majority of it, and the majority was not all of it, and what the couch was not managing was being managed by the specific form of bodily endurance that the burn had cultivated in all of them across its duration, the endurance not of effort, but of bearing, of existing inside a force that had no intention of stopping, and that you could not make stop, and that you therefore continued to be inside of. He heard it because the spine had a voice, and he had been listening to the voice for the full duration of the burn, and he knew what the voice sounded like when it was distributing, and he knew the difference between that sound and the sound the spine made in the instant before distribution became something else. He had heard enough structures fail across a career of engineering work to carry the acoustic signature of impending failure in the part of his professional memory that did not require conscious access. The recognition arrived before the reasoning. He knew before he could explain that he knew. The instant was brief. It was approximately 1/10 of a second in duration. The acoustic window between the field's final dropout and the response of the physical structure to the unaugmented load. In that 1/10 of a second, the primary spine was not distributing. It was at the threshold, the specific moment in any structure's response to overload, where the energy it has been absorbing reaches the material's accommodation limit, and the only available resolution is change. The spine had been built for exactly this, for distributing stress, for deferring failure across the full frame rather than concentrating it at a single point. It had been doing this since the sublight transition. It had been doing it at increasing load with decreasing electromagnetic support for hours. It decided to fail, not all at once. In sequence, from the highest loaded joints outward, the way the Icarus-class had always been designed to fail when failure was unavoidable. Distributed, not catastrophic. The load releasing across the full frame rather than all at once, which was the characteristic that had made it specific rather than obsolete in the first place, expressing itself now in the terminal event it had been designed to survive as long as possible. The structural integrity field did not flicker at the 2-second interval. It did not flicker at any interval. It cut off, not gradually, not in the progressive degradation that the interval compression had suggested was coming, but in the specific instantaneous way that electromagnetic systems end when the systems producing them reach a terminal state. One moment the field existed. The next moment it did not. The transition was not a fade. It was an edge. The hull received the unaugmented relativistic load in its entirety. The sound this produced was not describable in the vocabulary of ship sounds, not the distributed resonance of the spine doing its work, not the cascade sounds of mounting hardware at its failure threshold, not the acoustic report of any individual component reaching the end of its material endurance. It was the sound of the entire physical structure of the Icarus receiving a force input that no part of it, distributed or not, had been built to absorb without the electromagnetic supplementation that was no longer present. The sound was total. It was simultaneous across the full 87 meters of the hull. It arrived at every surface in the ship at the same instant, not propagating through the structure sequentially, but produced by the structure simultaneously, the entire vessel expressing the load in the same fraction of a second. In that fraction of a second, the Icarus achieved peak velocity. This was the physics of the situation. The structural integrity field's collapse removed the last active management of the hull's geometry under relativistic stress, and the unmanaged geometry responded to the unaugmented load by undergoing the deformation that the field had been preventing, and the deformation released the stored elastic energy in the primary spine simultaneously across all 87 meters, and the released energy added to the drive output's thrust vector for the duration of the structural event, and the combined output of drive thrust and released elastic energy produced, for approximately 1/3 of a second, a velocity that exceeded the burn's calculated maximum. Peak velocity, the expansion boundary's sensor threshold registered it. Vance could not verify this with any instrument currently active on the ship. The instruments were the manually relocated analog gauges in his direct sight line, the primary thrust indicator visible to Reyes, and the rebreather canister displays. None of them showed boundary proximity. None of them showed peak velocity in any unit that corresponded to the expansion boundary's location in space. What they showed was what they had always shown: the state of the systems they were connected to, which were the drive output and the atmospheric management and the remaining pressure readings from the engine room. The boundary was somewhere ahead in the fold. The fold was everywhere outside the hull. The hull was shattering. The shattering was not instantaneous. The spine had decided to fail and was failing, which was a process rather than an event. The process had a duration. The time it took for the primary frame members to release their stored stress in sequence as the field supplementation disappeared and the individual joints reached their failure thresholds in the order determined by the load distribution pattern that the Icarus-class architecture had maintained for the full burn duration. The joints that had been carrying the most load failed first. The joints behind them failed next. The sequence moved through the hull from the highest stress regions outward, the spine's failure propagating through the frame at the speed that physical stress propagation occurred in a titanium alloy structure of this mass and geometry. The bridge was still intact. The engine room was still running. The analog levers were still being managed by 4 engineers who could hear the propagation sequence arriving through the deck plating at its measured rate, and who kept their hands on the levers because there was nothing else to do with their hands that mattered more. Vance looked at the biometric readout, one of the manually relocated instruments in his sight line, a system he had positioned there not for his own monitoring but for the record, for the black box that was somewhere in the ship's surviving structure waiting for the event it had been built to survive. The biometric readout showed 9 signals: heart rate, brainwave pattern summary, respiration, the simplified output of the monitoring system that connected to the sensor arrays each crew member wore against their skin under their suits. 9 signals, all of them within ranges that the system's classification architecture called functional. No signal was showing the pattern the system classified as distress. Several signals were showing the pattern the system classified as something it had not been built to classify. A pattern that fell outside the training data of every physiological state the system had been programmed to recognize. Not distress, not the acute fear response, not the sustained cortisol pattern of extended stress exposure. Something the monitoring system's classification architecture encountered and could not name and therefore logged as an anomaly, which was what it was. Which was a physiological state that had no prior reference because the situation producing it had no prior reference. The system logged it and kept monitoring. Vance felt the hull release beneath him, not the couch's contact with the deck, which remained, but the deck's contact with the spine, which had changed. The propagation sequence had reached the bridge section's connection to the primary frame. The connection was releasing, the bridge modules mounting to the spine, yielding to the load, the geometry that had held the bridge in its position relative to the rest of the hull becoming a different geometry in the slow, progressive way that terminal structural events became different geometries. The bridge was not separating. It was descending, a millimeter of movement in the direction the effective gravity had been pressing throughout the burn. The movement that the spine mounting had been preventing and was now permitting. He reached for the reactor detonation trigger. The trigger was a physical switch, analog, hardwired, the kind of system that did not require functioning digital infrastructure to operate. A toggle cover, a rocker switch, a circuit that connected to the reactor's controlled detonation charge through a direct cable run that had been laid during the modification sequence for exactly this moment. The cover was a safety measure, not the Bureau's safety measure, but Vance's, a physical impediment against accidental activation that required a deliberate 2-step action to bypass. He opened the cover with his left thumb. He operated the rocker with his right. The reactor detonated. The charge was not designed to destroy the reactor. It was designed to use the reactor's remaining fuel inventory as a directed propulsive event, a controlled detonation that released the fuel's energy in a specifically shaped vector, backward along the hull's aft axis, in a burst of approximately 1/2 second duration. In the half second of the detonation, the force produced was sufficient to propel a heavily shielded object forward at a velocity significantly greater than the ship's current peak. provided the object was positioned correctly in the ship's aft section, and provided the detonation occurred before the hull's structural collapse reached the aft compartment where the object was housed. The timing was exact. The detonation wave traveled aft through the remaining hull structure. It passed through the sections that had already failed, and through the sections that were failing, and into the aft compartment where the black box was positioned. The heavily shielded data recorder, the chronicle of the burn in physical form, the record of everything the modification sequence had done, and everything the burn had produced, in a housing rated for terminal structural events and radiation loads and impact velocities that the Bureau had specified, and that the detonation now applied to it in the forward vector. The black box cleared the collapsing aft hull at a velocity that the collapsing hull could not follow. The singularity formed at the hull's geometric center as the primary frame released its remaining stored elastic energy in the instant of the detonation's peak. A gravitational event of approximately 1/3 of a second duration produced by the simultaneous collapse of a mass that had been moving at peak velocity. The singularity collapsed itself in the next instant, the mass too small and the duration too brief to sustain. What remained was the dispersal pattern, the thermal bloom, the molten armor's trailing field, the incandescent fragments of the primary spine shedding their stored energy into the void in all directions from the point where the Icarus had been. Vance heard none of this. The biometric system logged the transition in all 9 signals simultaneously at the same timestamp in the same fraction of a second that the primary spine had decided to fail, and the reactor had detonated, and the singularity had formed and collapsed. The logged pattern for all 9 signals was the same pattern the system had been logging as an anomaly throughout the detachment phase, the pattern it had no classification for, the pattern outside the training data, the pattern that did not correspond to any prior physiological state in the system's reference library. The system's final log entry read the pattern and logged it again. The biometric telemetry registered absolute euphoric peace, 9 signals, 1 timestamp. The final registered heart rates and brainwave patterns of 9 people who had flown faster than the universe had rules for. Recorded in the instant the singularity collapsed and the black box cleared the hull, and the detonation wave completed its work. Not distress, not the acute fear pattern, not any pattern the monitoring system had a classification for. The pattern it had been logging as anomaly since the detachment phase began. Logging now one final time in the half-second before the hardware that contained the monitoring system became part of the dispersal field that was the Icarus's remaining physical presence in the void. The black box was already gone. The vector was already set. The chronicle was already in the dark. We outran it. We actually outran the light. Chapter 17. The Black Box. The anomaly was not supposed to be there. That was the first notation in the Deep Salvage Operations Discovery Log. Not a description of what the sensors had found, but a record of the fact that what they had found was not consistent with the predictive models used to plan the survey route. The survey route had been planned for a region of the deep void that the models described as featureless, no cataloged debris fields, no mapped stellar remnants, no recorded navigational incidents, no historical traffic density sufficient to produce the kind of sensor return that the lead analyst was looking at on her display. The region was empty. The models agreed that it was empty. The sensor return said otherwise, and the sensor return was a direct measurement of the current state of the region, and the models were projections built from data that was centuries old, and the hierarchy of reliability between direct measurement and centuries-old projection was not ambiguous. She logged the discrepancy and requested a closer approach. The deep salvage vessel that was conducting the survey was not a large ship. It was purpose-built for exactly this kind of work. Long-range transit, extended independent operation, sensor arrays optimized for the detection of low-signal objects in high-noise environments, a crew of 11 specialists whose professional lives consisted of finding things in the deep void that were not supposed to be there, and determining what they were and how they had gotten there. Most of what they found was debris. The deep void collected debris the way still water collected sediment, slowly by the accumulation of small inputs over long periods, the aggregate of centuries of navigational incidents and decommissioned equipment and jettisoned mass building up in the regions between the established transit corridors where nobody traveled and therefore nobody cleared. Most of what was out here was ordinary, in the specific sense that it was identifiable and cataloged and fit within the existing framework of what the deep void was expected to contain. The sensor return from the anomaly did not fit the existing framework. The lead analyst had been doing this work for 19 years. She had the calibrated eye for sensor data that her profession produced, the ability to read a return and classify it quickly, to distinguish between the characteristic signatures of different material types and object geometries, to identify the patterns that meant something interesting as opposed to the patterns that meant another piece of navigational debris from another unremarkable incident. The return she was looking at now was not producing the classification response that 19 years of calibrated reading usually produced. It was producing the response she associated with returns that she had not seen before. Not the return of a class she could not identify immediately. The return of a class she was not certain existed. She logged a second notation. Anomalous material signature, recommend physical recovery for laboratory analysis. The physical recovery took 6 hours. The object was not large. The sensor return had suggested a compact, dense mass, and the physical recovery confirmed it. A rectangular form, approximately 60 centimeters on its longest axis, heavily fused along its exterior surfaces in a pattern consistent with extreme thermal exposure at some point in its history. The surface material partially vitrified, converted from its original state into a glass-like substance by heat that had been intense enough to reorganize the material's molecular structure without destroying the object it had been protecting. The object's exterior was not its original exterior. What the recovery team brought aboard was what had survived the event that had produced the vitrification, which was the interior, the core of the object, the part that whatever engineering had been applied to this housing had been designed to preserve. The vitrified exterior crumbled slightly when the recovery team handled it, producing fragments of the glass-like surface material that one of the analysts collected and sealed for separate analysis. The material's composition was unusual. The isotopic ratios were unusual. The specific pattern of the vitrification was unusual in a way that she found herself returning to as she began the preliminary documentation. Not unusual in a way that suggested misidentification, but unusual in a way that suggested an origin event more energetic than any she had previously documented, which was a conclusion she noted and set aside until the data could be reviewed by the full team. The decryption team had the object's internal storage array open within 22 hours of recovery. This was faster than the standard timeline for objects of this age and condition, which reflected both the decryption team's skill and the specific circumstance that the object's internal storage architecture was recognizable. An older design, certainly. A design that had been superseded by multiple generations of development in the centuries since whatever date the object had been produced, but identifiably belonging to a lineage of storage architectures that the decryption team's tools had been designed to handle. The architecture was not a mystery. The data it contained was a mystery. The decryption tools produced the data in readable form, and the decryption team passed it to the analysis team, and the analysis team began reading it, and the analysis team did not stop reading it for a long time. The lead analyst read the telemetry from the beginning. The telemetry began with an anomaly detection report, a sensor reading from a monitoring array, time-stamped several centuries earlier, describing the expansion of a propagating boundary at a velocity that the report's own assessment module flagged as incompatible with standard evacuation protocols. She had seen anomaly reports. She had filed anomaly reports. The specific anomaly this report described was not one she had seen documentation of, and the velocity figure in the report was a number that she read 3 times before she accepted that it was what the document said. She made a note. She kept reading. The telemetry covered a modification sequence, a series of engineering actions performed on a decommissioned vessel of a class she recognized, modifications that the records documented in precise technical detail, modifications that individually she could evaluate against her own engineering knowledge and classify as either reckless or impossible or both, and that in their accumulated sequence produced a vessel configuration that she could not immediately categorize because the category for it did not previously exist. She read the modification records carefully. She read them again. She called the chief engineer of the salvage vessel and had him read the modification records and asked him to tell her what he thought about them, and he read them and told her that if someone had actually done this, he would have several things to say about it professionally and personally, and was not certain which set of things to say first. She kept reading. The operational telemetry from the burn itself was the longest section of the record. It was also the section that required the most time, not because the data was difficult to process. The decryption had produced clean, readable output. The monitoring systems that had recorded the burn's progress had maintained their logging function through conditions that the logs themselves documented as terminal for progressively more of the ship's other systems. But because the data it contained required, to be read correctly, a sustained engagement with the specific physical reality it was describing. It was not abstract. It was not a summary. It was a second-by-second account of 9 people doing something that had been classified as impossible, in detail sufficient to reconstruct each stage of the process, with the specific precision of monitoring systems that had been designed for exactly this purpose, and that had continued functioning until the moment they could not. She read the velocity increments that Reyes had logged. She read the structural integrity field's flicker intervals and their progressive compression. She read the armor ablation data and the internal thermal gradient progression and the server rack failure sequence and the biometric monitoring outputs across the full burn duration. She read all of it. She paused at the biometric outputs from the final 3 hours of the burn. The monitoring system's classification notation appeared repeatedly in the log. Anomaly, unclassified, outside training data, attached to a physiological pattern that the system had been recording without being able to name. She looked at the pattern. She had medical training sufficient to read biometric outputs in a professional context. She looked at the pattern for a long time. She wrote a notation in her analysis log that read, "Final hours. Biometric outputs require specialist interpretation. Pattern does not correspond to any stress response profile in current literature. Recommend consultation with behavioral physiology team." She read the final timestamp. She read the biometric system's terminal entry. She sat with the terminal entry for several minutes. Then she called the full analysis team into the conference space and asked them to begin reviewing the telemetry data in parallel, section by section, using the portions she had not yet reached. She told them what she had found so far. She told them what the preliminary technical assessment of the modification sequence implied. She told them what the velocity figures in the operational telemetry said if they were accurate. She told them that she needed them to tell her if she was reading the data correctly, because she was reading it correctly and she knew she was reading it correctly and she needed someone else to confirm it. The analysis team worked through the night. At 0400 they began producing individual assessments. The assessments were structured documents, each analyst's professional evaluation of the section of the telemetry they had been assigned, with supporting calculations where the data required them, with explicit statements of the conclusions the data produced and the confidence level of each conclusion. The lead analyst read the assessments as they arrived. Each one confirmed the same things in the register of its author, in the specific vocabulary of their specialty, with the specific quality of certainty that people who have checked their work repeatedly achieve when the work keeps producing the same answer. The velocity data was accurate. The burn had occurred. The vessel had achieved the velocity the telemetry recorded. This was the conclusion. The supporting data was thousands of pages of detailed operational records from a monitoring system that had been functioning at the moment of recording and whose output bore no markers of corruption or alteration. The conclusion was what the data said. The confidence interval was as high as the analysis team's methodology allowed, which was very high, which was the interval reserved for the conclusions that the methodology was most certain about. The lead analyst wrote her summary assessment. She wrote it carefully, in the language her profession used for findings of this magnitude. Precise, conservative, explicitly qualified where qualification was warranted, and explicitly certain where the data supported certainty. She wrote it in the specific register of a scientist who has found something that changes the framework of what the field considered possible, which was a register she had read in the work of others and had not previously had occasion to use herself. The vessel designated Icarus in the recovered telemetry had achieved a velocity sufficient to demonstrate that the theoretical sublight barrier was not a barrier in the practical sense, that it was, in the specific language the engineering team had used in their own documentation, a suggestion. The suggestion had been disproven. The proof was the telemetry, 347 years old, recovered from the deep void in a housing that had survived the event that produced it, scorched and fused and partially vitrified, drifting alone in a region of space that was empty except for the dispersal field of incandescent fragments and the solidified droplets of molten armor that marked, across several hundred cubic kilometers of the void, the trajectory of the thing that had come through here at this velocity on this date and had left this record of its passage for anyone who arrived with the instruments to find it. The framework of galactic physics had a new data point. The data point was not a theoretical addition to the framework. It was not a mathematical extension of existing models, not a projection from prior observations, not an extrapolation that required assumptions to reach its conclusion. It was an observed event, documented in real time by functional monitoring systems, preserved in a physical medium that had survived 3 centuries of drift in the deep void, recovered by a survey vessel whose instruments were sensitive enough to detect its presence, decrypted by a team whose tools were adequate to read its contents, and analyzed by professionals whose methodology was rigorous enough to produce conclusions that the confidence interval supported at the highest level the methodology could assign. The universe had been demonstrated by direct evidence to be navigable at velocities that the prior framework had described as impossible. Not navigable in the conventional sense, not survivable in the conventional sense, not achievable by any method that the Bureau's specifications contained or that the framework had anticipated, but navigable in the sense that the Icarus had navigated it, which was to say, by building something that the specifications did not permit, by removing every constraint that the specifications imposed, by accepting every cost that the removal required, and by flying the thing that remained in the direction that the physics demanded until the physics either validated the calculation or it did not. The physics had validated the calculation. The crew had known that at some point in the final hours of the burn. The biometric telemetry said so. The pattern that the monitoring system had logged as anomaly and unclassified and outside training data was the physiological expression of people who had done the thing and were in the process of confirming that the thing had worked, and who had felt, in the specific, unmediated, unreported, analog way, that human bodies feel things at the threshold of what they have been designed to survive. What it meant to be right about a 0.03% probability when the alternative was 0. The lead analyst finished her summary assessment. She read it once from the beginning. She made 3 small corrections to the language. She filed it. Then she looked at the object on the analysis table, the scorched, fused data recorder, the vitrified housing, the thing that had drifted for 3 centuries in the void and had come from a ship that had gone faster than the universe had rules for, built by 9 people who had decided that rules and survival were not, in the specific context they were operating in the same category of concern. She thought about what they had built and what it had cost and what it had proven. They didn't just build a faster ship. They proved the universe was only a cage if you were too afraid to break the bars.